All right. Well, we are here and gathered in El Paso Teller County 911 Authority. Thank you very much to Renee and her team for hosting. And we are here with. I shouldn't be. Can you guys hear me online?
Loud and clear, Jennifer.
Loud and clear? Okay, great. Just checking. I would suck. But we are here for the next in our 2025 GIS informational series, and we are grateful to Datamark, and we have Deb and Lauren and Greg here to present to us on a deep dive in the NINA docs for GIS. And so I will give our current and disclaimer that the only official record of this meeting will be our YouTube recording that we will put out. I am also taking notes on our questions so that we can take them to our Ask Me Anything panel that's going to be held in October. So thank you very much for being here, and I will turn it over to Deb and Lauren.
Okay, I've unmuted, so hopefully once again I'm coming through loud and clear.
And can everybody hear Deb?
Yes, but is she going to go 88 miles an hour?
Oh, hey, I'm going to try not to. I'll slow it down and really trudge through the tables. Don't you worry. Okay, so yes, doc breakdown. Thank you, Lauren, for adding the graphic of doc. We're here to do a deep dive into some of the NINA standards and informational documents and try to do it in as interesting and non-snoozeworthy fashion as possible. Hopefully not a million miles an hour. Thank you, Matt. So I'm Deb Rosenbaum, a client success manager at Datamark. Been doing public safety GIS for over 21 years. Currently, I'm a co-chair of NINA's NG911 GIS data model standard. So a lot of what I go into on the data model will be geared towards the latest version that we are currently working through. And that's my little intro. Lauren, you want to say hi?
Sure. So I'm Lauren DiGiovanni. I'm also a client success manager with Datamark. I've been in public safety GIS for 5 or 6 years, regular GIS for like 15 roughly. And yeah, I'm from Colorado, so I'm local. Well, not originally from Colorado, but I live here now. So I'm local, and I'll be going through the latter half of this presentation with you all.
Yes, so we are going to mix it up a little bit, starting with the data model and then a break, maybe not quite the halfway point, where then Lauren will pick it up to talk about GIS data stewardship and GIS data transition. And then I'll wrap it up at the end with some current and future NINA docs that are in process. Just to clarify too, the first one I talk about is a standard. So it is an ANSI standard. That means that we have to be very, very specific and particular about how we draft that standard and that it meets all the particulars for a nationally accredited standard. And then the informational docs on stewardship and transition are about, okay, that's great. We know the structure, we know the standard. How do we achieve it? How do we get there? How do we build it? How do we maintain it? So that's what we're going to be going through. And again, I'm starting off with the GIS data model. This is a work group that I co-chair and have since 2020. Yeah, about 5 years now. Just to level set, when I talk about the world of standards, this is one of my favorite little graphics. Anyone who remembers Ziploc and yellow and blue make green. This is a reference to the I3 architecture. So the document in yellow, that is the full-blown next-gen 911 system, EZNet, and functional element architecture document. A mere 500 to 600 page standard document that anyone is welcome to read, especially if you have trouble sleeping. Then there's CLDXF, which is Civic Location Data Exchange Format. And these are the standards that truly govern how civic address location data is conveyed in a next-gen system. There's a profile for the United States, US, up there at the top, STA 004. And now Canada has their own profile that came out within the last year, STA 029. And these are, to handle slight differences in how location is conveyed between the US and Canada, things like that. But both of them, along with I3, feed, inform, and dictate the GIS data structure that's in STA 006. So anything we do in the GIS data model, we don't go rogue and throw a bunch of stuff in there that is ungoverned or unstandardized or, you know, doesn't have a purpose. Everything that is about how locations are validated and used to route live 911 calls is governed really by those two standards. And we are creating the geospatial structure for how that works in the next gen system. Just a little background. When the versions of the data model standard, the first one was worked on for 8 years from 2010 to 2018. I was a member of that work group the whole time, and that was quite the rodeo. It was very interesting because it was the first attempt to put a GIS structure to this concept of next gen and geospatial call routing. So it went through some changes in the group along the way, but it was really based off of the first and second versions of the I3 standard that were published. So version 1 and version 2. Then version 2 of the data model was the first one where I stepped into the co-chair role. It was worked on from 2020 to 2022, and it was really about expanding it beyond the US to be no longer US centric. It was country neutral, and that's largely because the country of Canada is deploying NG911 following NINA's I3 architecture and data model, and they're doing it the whole country all at once. It's a different model where US is going state by state, or sometimes even within states, region by region. The entire country is going live with next gen. They're following NINA standards. And so we needed to look to expand and make accommodations for terminology and things beyond the United States. And that you'll see as we go through this, it caused a little bit of difference that does prompt some heartache in some ways. But again, it was for a broadening use of that model and look to, in the future, further expand into Mexico, so all of North America, and even beyond beyond this continent. Now, version 3 is what a lot of this I'll have a lot of stuff included that's part of version 3 because that's due to publish, fingers crossed, by the end of this year. And it was a big version change. So version 2, yes, there was some broadening, some changes, but version 3 has a lot of changes because there was a new version of I3 that was published, the 3D GIS requirements, so looking vertical at Z-axis, that kind of thing. We had to take those requirements into consideration. The CLDXF version 2 for the US and the Canadian version, those both published within the window that we were actively editing. So we had included in our charter consideration for if they're going to publish, yes, we will align with that, because it would be kind of silly to, while we're actively editing, to just ignore this big standard that had published. And then a relational structure. So primarily the document to date has been what's called a flat file, individual layers, and not a lot of links to related tables or things like that. There was a plan years back that eventually the entire data model would shift to a relational structure. That is not the plan anymore. What has happened instead is, because at the end of the I3 standard, there was what they called a relational structure for the spatial interface that was a little bit in conflict with some things in the data model. The decision was made to remove that from I3 and put all GIS data structure within the data model. So you don't have two big standards with conflicting and sometimes opposing and confusing data structures in them. So relational has now, that appendix from I3 has been moved into an appendix of the data model. And then we aligned all of the attributes and fields within it, so everything is harmonious, and you can, the goal is to be able to easily convert between the two. So that's the history of the data model. If I haven't put you to sleep yet, I just want to level set again on Next Gen 911 and why we focus so much on a common data structure, why it's important, because GIS is coming into play not just at the end state after a call has routed and hit the PSAP and it's in your PSAP mapping and your CAD and your call handling mapping. It is coming into play far before that, first as a location validation instead of your MSAG. Instead of looking to see if something is MSAG valid, you're looking to see if a location is GIS valid, basically. The GIS data being housed in what's called the location validation function. So you're using GIS data to validate a location as people are signing up for service at addresses, at civic addresses. And then it is also in this emergency call routing function. This is where GIS data is stored, like your PSAP boundaries. That's the boundary that's being used to actually route a live 911 call. So the call is placed, it hits the EZINet through the border control function. It gets to this emergency services routing proxy that really replaces the selective router. That selective router, which is now the ESRP, reaches out to the ECRF, where GIS data is being used to validate the location and determine which PSAP to send the call to. It comes back to the ESRP, goes to the right PSAP, and then you still have your CAD, your call handling, and all of your mapping. And your GIS is feeding all of these locations, ideally the same data, same structure, same format, everything is being used in all systems. I will say it'll be a little while to get to that fully realized end state, but that is the goal, is to have this one data set used in all places. And when I talk about location validation, there's a lot of different ways. Those that have worked in PSAPs and worked as dispatchers and call handlers, you know that location can be conveyed a lot of different ways, verbally by the caller or automatically coming in through the alley and through the system. The top two are the more traditional ways that NG will handle a location for routing a call. So as a civic address or as a set of coordinates, a latitude, longitude, a geodetic location is what they call it. Beyond that, there's still all of the different ways locations are validated when you are handling a call and people are verbally communicating. You know, they don't know their address. They're maybe at a ball field, at a park, and their kid is playing and the kid's been injured and they're trying to convey where they are to get emergency services there, right? So they're at a park and maybe they're at ball field 3. Or you're on a highway and you have a sense of what mile marker you're near on which highway. Or there's a traffic incident at an intersection, 8th and Main. These are all ways that locations can be validated in CAD and in mapping that are even that go beyond how locations are validated and used to route a call. So it's routing a call versus routing a responder vehicle to the right location, right? So all of this is handled though by GIS data within the mapping system, within the ECRF, within the LVF, as I said, and to have it all work together to have true interoperability within your own systems, and even beyond that to statewide systems, your neighboring jurisdictions, neighboring PSAPs. You have to build your GIS data, the fuel for all of this, to a particular standard. And that's the GIS data model. So who in the room here or online, if you can raise your hands, like who considers yourself a GIS professional? Do we have GIS professionals? Yes. Some, come on, out yourselves. Yes, and then so who's on the flip side then, who's a 911 professional, call taker, dispatcher, PSAP manager? Okay, so it's a good mix, and this is a good presentation. Again, I'll try not to put you to sleep with the details, but in the standard, what we looked to do was to categorize these GIS layers by 3 different status categories, basically, whether they're required, strongly recommended, or just recommended. And I'll say that for a very data heavy kind of nerdy topic, people on the data model and in these groups can get very passionate about the way the data is structured, architected, and its use and purpose in these systems. So we used to just have a list that said, here's the required, here's the strongly recommended, here's the recommended. We built it out in more current versions of the standard to say, here's what it's required for or strongly recommended for. This is where it actually may get used in these systems. And then beyond some of the functional elements, but some additional uses for all of these layers that go into the map display and CAD and those types of things. So these are the required layers: your road centerline, address points, your service boundaries, PSAP, fire, police, EMS, and then provisioning polygon. And I'll go into each one of these individually to kind of provide some more detail. Visually, of course, road center lines, the line work that you would see, points being points on structures, and even down to the subaddress, like apartments or lots within mobile home parks or campgrounds, things like that. You can have subaddressing down to the detailed level. And then your polygons that are all these different polygon layers for PSAP, which is then for the initial call that's routed is using your PSAP boundary polygons. And then your fire, police, and EMS are the responders that are being sent individually. And then of course, traditionally in legacy, you would see those three combined into like an ESN layer that correlates to your ESNs. And then provisioning polygon too. And again, I'll get into all of these. This is where you get to see a lot of tables. And again, I'll apologize in advance, but it is a data structure. There's no other exciting way to convey a data structure than by diving into tables. I just wanted to point out where the column in the center that says required, that is where I highlighted things yellow if they are required or left them gray if they are not. There's pretty much a standard structure for the first about 5 fields in every layer that follow the same pattern for a discrepancy agency ID, which is pretty much what it sounds like, the agency that would receive a discrepancy if there was an issue with the data, some flaw or error that needed to be corrected in order to properly route a call. The date updated, again, what it sounds like the last time that feature was touched or updated. These things of effective and expiration date are interesting. I want to say in the first version, they might have been required, and then it turns out that was really complicated to manage. So it is something you can do in your data where if, say, roads are being built, but they're not fully traversable until a certain date, you can put an effective date in your data so that it only becomes this live routable, call routable or vehicle routable feature on a certain date. Or if you want it to expire or be inaccessible for a period of time, you can do that as well. And you can use your attributes to do that. Now on the flip side, you have to have your NG core services capable of reading those dates and acting on those dates. So in everything that I go through, there is this standard core structure that is meant to be truly for fostering interoperability. But you always have this caveat on the side that says, but in whatever state you're in or whatever deployment you're in, you have to work with your NG core service provider to see what their requirements are and how they may have interpreted the larger I3 standard to build their solutions. And are they capable of interacting with all of this or not? And the fact that effective date and expiration date are not required, they may not have the capability to do that. That could be like a value add to their solution. It's hard to say. So some things you kind of do have to navigate deployment by deployment and how the data is built. The unique ID is universal to all of them. This is how you keep track of these features. If there are changes, if there are errors, as those errors are corrected. And there's a structure, a specific structure to it involving both local unique IDs and a globally unique NINA global unique ID. And it is best practice to have that be static, a static ID that doesn't change. Some databases treat it differently, but ideally that would be a static ID. So some places then you have a left, your actual ranges, your house numbers might have a prefix. This is not common, but because this is built for multiple countries, and building out for much more broader use, there are these conditional fields about address number prefixes that are conditional, and then the range fields and your parity fields, these are pretty core. This is when you're looking to validate a civic address, these are required. You need to know what the ranges are and where they fall on the center lines in order to validate that location. This is kind of interesting to me because this is all of the granular breakdown of a street name. It's we'll get to the legacy fields in a minute. Legacy fields are really what you would see in your MSAG. So if you've dealt with an MSAG, there's like 4 street name fields. This expands it out now to 9. It was 8 in a previous version. And then they added in version 3 now, this direction of travel. And that is aligning with CLDXF that added that in as an element. And that means for like northbound, southbound, when you have interstates and highways and things that have a specific direction of travel like that. Every time I read it, I think it makes me think about the way the line is drawn and direction of travel. That's not it. So it's a little bit, it can be a little tricky, but this was added specifically to deal with those things like on-ramps, off-ramps, and highways with big divides that are use that northbound, southbound, eastbound, westbound type of designator. But the only thing in here that is truly required is that core street name. Because there are streets that have just that don't have designators, that don't have pre-directionals, that don't have anything else to them. It's just Main, or it's just Broadway, or whatever it happens to be. So you have to have something in the street name field, but that is the one requirement. Everything else beyond that are conditional. And what I'll say about conditional, the definition is basically how you would populate a conditional field. There's something called a business rule. Business rule generically states like if something like this exists, you have to populate it. So if your street name has a pre-directional, you have to make sure you populate the pre-directional. If you are in a place where you have quadrant-based addressing, so First Street Southwest, First Street Southeast, that kind of thing, and you have those post directionals, you have to populate them. The business rules are housed in the CLDXF standard because that is, again, what governs the true location profile. So it is a bit of a, you read one standard that refers you to another, refers you over to CLDXF, and that's simply because we made the distinct decision not to copy and paste everything from CLDXF into the data model, because then you've got two standards in two review cycles and two publication cycles that could get out of sync. So we just said the business rules are housed in CLDXF. It might be the US version, it might be the Canadian version, depending on where you are. But to figure out how to populate these attributes that are conditional, you can read the business rule that governs it in CLDXF. And then we go on to, as I mentioned, these legacy attributes. So legacy ones are the ones that have to match character for character to your MSAG and ALI. And this has been kind of a fun one to work through, fun in quotes, to work through in the data model work group, because a lot of times when you're doing these checks, and I know Lauren's going to get into a little more particulars about the comparisons of MSAG and ALI and how to do that and the importance of them. But you can get a little bit lost in, okay, if you're looking at your ALI database and you're trying to see if they all geocode and find a home in your center lines and your address points. If your street name is Lakeview 1 word or Lakeview 2 words, which one is correct? Which one is incorrect? The main thing, and this is, it's hard for people to maybe wrap their minds around, is as long as they match, it doesn't matter. It's going to sound kind of weird, but like if your MSAG is out of date and kind of ungoverned and has a bunch of bad information in it, not that anyone here has that problem, I'm not pointing any fingers, you can make it easy on yourself by just making the GIS legacy fields match whatever is in your MSAG, and not necessarily have to go down the rabbit hole of what is correct and what is incorrect and down to the nth degree. They need to match character for character, because the most important thing is to be able to convert that into the NG format back into these fields where they are fully spelled out and governed by the CLDXF, and they likely 100% match what is the legal street name and everything that it needs to be. So as long as you have everything correct, parsed out, and populated here following those rules, you can follow whatever the MSAG has. If it's cumbersome to update the MSAG, you can just make your GIS legacy fields match it and not stress about it. Or if you're diligent on, nope, it is not that spelling, Lakeview is 1 word, not 2 words, you can go into your MSAG and make the change. And as long as it gets updated in the MSAG and that communicates on to the ALI database and all of the telcos that feed into the ALI database, as long as they match character for character, you're fine. That's the most important thing. And these are all fields that will technically at some point in the future go away. They have this little asterisk by them because they're considered legacy fields. When all of your selective routers are gone, when all of the legacy componentry is gone, these fields are gone as well, and you no longer need to maintain them. When will that happen? That is the big question mark, right? And one of the things Lauren's going to go through is the transition document. We're going to live in transition probably for a long time. Get comfortable there. That's why the data model is built this way. We know it's not going to be a sudden switch from legacy to next gen. You're going to have to live in this transitional state for a while. And then this is a change with the version 3 that people look at this and they go, what in the world are administrative levels? Administrative levels are what are formerly known as your state, county, incorporated municipality, unincorporated, and your neighborhood. And people get very kind of tense in the shoulders when you start saying, well, why can't we just call it states? Why can't we call it counties? Canada doesn't have states. Canada has counties, some places, not others. And again, with the expansion to be not US centric, we needed to go for a non-US centric naming system. And this is much more global in nature. And this is also in the conveyance of location, the actual format. Today's systems are ALI. Next gen systems is something called PIDFlow. PIDFlow is built off of CLDXF. Yes, I'm throwing so many acronyms at you guys, and I apologize for it. The thing to take away is PIDFlow is the new ALI. PIDFlow built off of CLDXF. This is an XML structure. These elements have these tags to them, and these tags were always A1, A2, A3. If you've looked at any NG Core services and you've looked at the structure of PIDFlow and how location is coming through on these systems, you will see these tags, and it won't say state, it won't say county. It never did. It always said A1, A2, A3, et cetera. So this is actually aligning with the true next gen format even better and putting it in the GIS data. People are going to be confused for a little bit. They're going to wonder what all the numbers mean. You're going to have to mentally kind of convert it. I still do. I've been swimming around in this for years, and I still have to mentally go, why doesn't one start with country? No, country is country, but A1 is state. And it takes a little bit of getting used to. But this was, again, a change that started with version 2 and is more solidified with version 3. And again, version 3 coming out by the end of this year. Then there's things like postal codes. None of these are required. These are all optional or just not required fields. Postal codes, postal communities. And then these interesting ones of road class, one way, and speed limit. This is where we start to get into this interesting, is this for routing a call or routing a vehicle questions? Is this purely for location validation and call routing, or are we looking at map display here? And this is where the data model has consistently, since 2010, when it first got started, has a bit of an identity crisis over it's a next gen GIS data model, but there's language that says it is map display as a consideration. And so you don't focus purely on what's needed to route a call. There are these considerations around map display as well. And these, again, are about map display and more about routing a vehicle. And I'll get into a small conversation about something called the mapping data service. But again, I don't want to overwhelm everybody, so I won't go too deep on that. But so we talked about road center lines. And road center lines are pretty universal. Just about everywhere in the country has a road center line layer. It's been the core foundational layer of mapping systems and legacy systems and into next-gen systems for the longest time. Address points, at the tail end of the first version of the standard, they did make them required, but with a caveat that says they're not required to be complete. And truthfully, no GIS data is ever complete because you're constantly building and changing, adding roads and adding buildings and all that stuff. But recognizing that address points were a heavier lift and that not everybody would have them built, it would take time, money, resources, all the things. They wanted to build it in as a required layer because it is also a much more accurate way to describe and locate where a structure truly is. They made it a required layer just before version 1 was published. with that caveat. But then as you're building the data, you want to make sure that as you build your address points and your center lines, they line up as accurately as possible. Because the thinking is that when you're validating a location, first you're going to try to find an address point, because again, it's going to be right on the structure. As opposed to, this is a visual that shows something called a fishbone analysis. So this shows where an address point is versus where it would geocode off of a center line if all you had was a center line. And at the beginning of these ranges, you're not too far off. You're pretty close. As you go down the block, you start to see how the offset and the fish bones get further and further stretched. And so if all you have is a center line to rely on, you may not be in front of the right door. You may not validate right in front of the door you need to go in. And depending on the nature of the emergency, if the structure is on fire, maybe it will be obvious which one you need to go to, right? If it is a home invasion or somebody that is texting and can't vocalize where they are and you need to kick down a door, you want to kick in the right door and you want to make sure you're in front of the right home and as close to the right structure right off the bat as possible. Obviously, posted house numbers, assuming everywhere has posted house numbers. I've encountered plenty of places that people don't. You just want to give the best data and the best tools to the responders as possible. So not just for validating a location and routing a call to the right PSAP, but then also getting the responders to the right location to handle that emergency as well. And I always like to point out too, with data, this is just fun. When you do these fish bones, you're kind of like, what are these big green lines cutting through everything? Like what's going on here? And that's when you check your data and whatever you have on your address point and whatever you have in your center lines is so off kilter that they are nowhere near each other. And it could be a simple misspelling of a street name. It could be the wrong assignment of a community. It could be a handful of different things. Over here on the left, it looks like here's this line that lands in the pocket of a bunch of units for building 313. Well, this one says 413. So somebody made a mistake maybe when they were adding another point, put the wrong house number on it. So that geocodes to that point, but the center line way off screen to the north, right? So I put this for a visual because everyone's probably tired of tables and I'm about to go into more tables, but also it's just a good way to visualize how you want your data to line up, not just individual layers, but across multiple layers. So for site structure address points, again, same 5 initial fields, required capabilities or designations are the same. You get right into, because this is a single point, not a center line with a left and a right range, you have fewer fields, but they follow the same pattern as the road center lines, where country and state, or A1, are required, and then you get into these conditional fields. Now you have, instead of ranges, you have address numbers, and you have a bunch of ways and breakdowns around those address numbers. There could be a prefix, there's the core address number, there could be a suffix. And then in CLDXF, they added this address number complete. So basically a concatenated field where you pull it all together. I can't remember the definition on that one, why it was done. To me, that usually means for map display, but I know there was a different purpose. Point being, there's not just your street names have parsing to them, but the numbers themselves on address points, you can get very much more granular and parsed out in representing those. And then distance marker is formerly known as milepost. Again, US has miles, Canada has kilometers. So we don't have just mileposts or mile markers, we have distance markers. In Canada, they may be kilometer markers. And then these are the same exact street name breakdown as you saw in the center lines. So a lot of things start to be the same from one layer to the next. These are those legacy fields. I just kind of drew a box around them. Again, the same legacy fields. One thing that got added in version 3 is this legacy county ID. In your ALI and your MSAG, there used to be, or there is, I should say, the county can be conveyed as something like a FIPS code. It could be numeric or alphanumeric. And that was not present in the GIS data. And it caused some issues with NG911 deployments where you're trying to convert from legacy to NG911, but NG has a spelled out county and Legacy has a FIPS code, and they just weren't matching, weren't translating effectively. And it was a misalignment between I3 and the data model. So we added another legacy field to help facilitate that conversion. And then we get into a whole slew of subaddress fields. We used to have a structure of landmarks and landmark name parts and related tables, and it was very complex, and I don't know of anyone that ever implemented it. And so one of the main goals from CLDXF version 2 in the US was to make this depiction of subaddresses a lot more logical and granular and useful as opposed to that former structure. So it has things like a site and a subsite and a structure. So you can think of a park. Within a park are ball fields. Within ball fields, maybe there's concession stands for structures, right? You think about these sort of nested ways of describing areas and sites. Within a structure, you don't just have floors, you have floor labels and a floor index. And I'll get to that when I talk about the Z value a little bit as well. It got more granular into things like wings, units, section, row, room, and seat. Now this is if you are building your data, your GIS data down to this most granular detail of every last seat that has a fixed phone that may be validating and routing a call, multi-line telephone systems, things like that, desk phones that have your buildings and your layouts mapped down to this degree, and you have a point representing each one of these. I will say I don't know that I've ever seen it data built out down to this level. It is rare, but at the same time, the capability is there. And so you want a structure to make it universal if people decide to do their data down to this granularity. And then it continues into, again, location marker. Location marker is different than distance marker. This is for things that don't have a specific distance. If you think about like trailblazes on recreational trails, buoys out in waterways, things that aren't necessarily based off of a prescribed distance between them, but have a label that could be used by someone in an emergency to reference where they are and where they need help. Additional location, there's still this, anything, it's kind of a catch-all kitchen sink field, additional location, anything that you can't fit in site, subsite, structure, floor, all these things, there's still additional location as a way to have a catch-all field. And then additional data URI is if you have a additional data repository that you can reference as well. If there's even more information about that building, that location, you can pull that through a URI. Place type and placement method are about where the points themselves, where and how they're placed and what they are, what type of location they are. Latitude, longitude, obviously. And then these are some interesting ones: elevation, altitude, and height. And these come from the 3D GIS requirements, the requirements document. And pictures are so much better. So I hope you guys can agree. What these are, to try to make it more interpretable, altitude, when we talk about, does anyone here that works in a PSAP, are you starting to see Z-axis, Z data coming through your alley? Has anyone seen these values come through? If not, it could be that it's coming. It's just that your systems aren't parsed to view it, right? There's a lot of stuff in there that if you're not specifically parsing your mapping and your CAD to view it, you may not be seeing it. But what is being sent for your Z value is something that's called height above ellipsoid. And who doesn't love these truly geeky terms in GIS of an ellipsoid? And as I try to walk through this a little bit, I had to come up with a graphic because it doesn't make sense otherwise. It's over my head, it's over anyone's head. An ellipsoid is if we really lived on a perfect blue marble, right? And there was no texture and there was no bumps and dips. That's what an ellipsoid is. It's a smooth mathematical representation of the Earth. The Earth is not a perfect blue marble. So terrain is the approximate irregular representation, things like the Rocky Mountains that we're pretty close to, things like, you know, valleys. There is a lot of texture to the actual Earth's surface. So when the vertical location of a cell phone is given as height above ellipsoid, it's kind of a gibberish number that doesn't mean much. It's hard to interpret. And for the majority of the United States, it's a negative number, even in Colorado, where, you know, Denver, Mile High City, mountains at 14,000 feet, it still would be a negative number. And that's based off of this smooth model. So how does that help you? How does that help you in a 911 center actually figure out how high up in a building or above the ground somebody is? So what was determined is, again, the terms to help correlate this is altitude is that height above ellipsoid. So a caller in this top floor of a building, their altitude is what's coming across as the Z value. Elevation is actually at the ground floor, or feet on the dirt, or the main ground level of a building is your elevation. And then the height is the difference between the two. So I know there's discussion about it being more useful if Z value was communicated as height above terrain instead of height above ellipsoid. I think I agree. Anyone can probably agree that'd be a lot more sensical. You're still going to have the, okay, but what if it says you're 15 floors up, but that building didn't identify floor 13 for superstitious reasons. So you're actually on the 14th floor. There's so many, I'm not going to go down there, guys. I'm not going to get into all of that. If you want to have those conversations, I highly encourage you to join the indoor group that's going on, because that is a conversation that comes up all the time. But these are now things that are attributes that are built into the data that can help identify, again, if you've built your address points out to this granularity and this level so that you know that these apartment units are X number of feet above the air, that's their, above the ground, that's their height. It is useful information if you match to that point and you can see in the attributes that that's whatever, 100 feet off the ground level. You know, it gives you a little bit of a better idea what floor they might be on if it doesn't immediately correlate, that kind of thing. So hopefully that gives a little better insight into it. I've been talking a lot and nobody's asking questions. Have we seen any on the Zoom? I just want to check in. Oh, we don't. Okay. Sorry, audience. Hey.
No.
All right.
Yeah,
Can I unmute them? Do they unmute themselves?
they can unmute themselves.
All right, go for it, Rachel.
Yeah, hi. There is no way to submit questions.
Yeah, there's no chat, so you can go ahead and speak your question.
Oh, goody. Okay. Well, in the site structure address point model and the fields you were just speaking of, being a literal person, I think, okay, 99% of the time these will be for sites or structures. But we're kind of mixing and matching because we're talking about distance markers, things like how far you are up a trail in the mountains, or how far you are between Boulder and Denver on the turnpike, or which buoy is which out in a body of water. So those are points, but they're not site structure points.
Right. And so I will get into when I get out of the required layers and into the recommended layers, there's two different ways that you can represent those points. You can either build your mile markers into your address points because you are validating them as locations, or you can, or you can have a separate layer that's more for visual map display, and we'll get to that in the recommended layers, where you can have a distance marker layer and a location marker layer that depict and can be symbolized differently and labeled differently purely for map display to show where those mile markers are. Does that help?
Yes, I mean, there's many ways to represent it, either
Yeah.
all in one layer or across many different layers, just depending on your business process.
Exactly.
Okay.
And how you're, again, you're hopefully building data that can be used for next gen call routing, as well as your CAD and your mapping systems in the 911 center.
Mhm.
And depending on how those CAD and mapping systems validate locations, some of them require, even if you're going to validate off a mile marker, that you need that mile marker information built into the address points to validate off of that. And that's where there's those fields accommodated for in the address point layer, but you can also have them as a separate visual only for your map display. So hopefully that helps. Is there anything else to that you want to dig into?
Not right now, thanks.
Okay. All right. So 3D terms, again, in a visual that I hope helps. And then I'm going to get into just a couple more of these required layers. This is actually one schema to rule them all in the service boundaries. It is one structure used for PSAP, fire, EMS, and police. And yes, the police one is the one that tends to make shoulders tense up a little bit too, because it used to be called the law layer and now it is police. And that's once again a non-US centric term. In more international context, police is a more general term used for law enforcement. And so that's why that change was made as well. But this is the same structure, the same data structure is used for all of these different polygon layers. So you've got the same 5 initial fields, and then you go into your agency identifier. And then these things called these service URI. You're like, what in the world is that? As a GIS data provider, you're not going to have to worry about that until you're in a live next-gen deployment. Those URIs are created and built generally through the creation of that network and through your NG Core service provider. And you have to ensure that the right polygon has the right URI, because this URI is basically the network address for that PSAP in each polygon. This is what is used by the system to route the call to the correct location. So it can be a little intimidating for GIS folks to be like, if you get that URI just a little bit wrong, it could misroute a call. And that is the truth. But again, you don't have to come up with them on your own. They are provided by your NG Core service provider. You just have to ensure that they stay accurate. And once provided, I would say they rarely change. But you would ensure that that stays accurately populated. And usually you have a QC check that has a domain or a list of acceptable values for those URIs. You'd be able to check that before it's provisioned to make sure you're not inadvertently provisioning something that is the wrong URI.
Deb.
Can I ask a quick question? Is that normally your SIP URI that your service provider is providing you for routing of the SIP calls across DSUNet?
Yeah. So it's the network location for that NPSAP that's going to receive the call. Yeah.
So your CPU vendor should have that.
Yeah. And then the URN is what distinguishes between the different services. So there's a URN for fire, for PSAP, for police, for EMS. That's kind of like the filtering agent. When you're routing a call, it'll first, search the URN for the right service. The URN that says PSAP will be what's used to then find the right polygon and then match the right polygon, the right URIs, the right address to send that call. And then we get into things like service number. This one was interesting to me because some places populate it and some places don't. Some people just put 911 as the service number for that. It's a kind of an interesting field. And again, depending on your core service provider, they may use this in different ways. And it's not a required field, so it's a little bit ungoverned. The agency V card URI, again, contact information for that agency. And then the big thing is the display name for the PSAP, how that comes across your system. So some people will, it is a text field limited to 60 characters. So some people it's generally enough characters for a PSAP name, but we haven't heard anything to the contrary that asks to expand that. But that's, again, the name of the PSAP or the service, the fire department, EMS, police, depending on which layer you're operating within. And then the last of the required layers is this provisioning boundary. And this is always a little interesting too, because this is a layer that only exists in the data model. It doesn't exist anywhere in i3 architecture. We've had many back and forths with the i3 group about do they have a use and purpose for this, or is it purely for, from the perspective of aggregating GIS data from beyond the county level to regional and to state levels? Most counties tend to operate within their own area. They may, for their own systems, have some features that go outside their technical jurisdiction or outside their boundaries in order for vehicle connectivity or routability, things like that. But they have features that go outside their area but are required for their map display and their functional use. But when you're providing data to a next-gen system, you have to define the boundary for which you're truly the authoritative source of data, and trim off anything that's outside that boundary. Because otherwise you end up, everyone around you is doing the same thing, and they'll have features that bleed into your area, and they might be out of date, and they might be inaccurate, and they might, or just purely redundant. And so the provisioning boundary is what defines those fence lines or cookie cutter boundaries, to make sure as GIS data providers are sending their data to a larger aggregator, that they don't have a lot of extraneous, conflicting or unnecessary features that are being provided, and that it truly defines the responsibility that says any errors within here, I am responsible for and I have to fix. And the same with all of the neighbors, again, as it gets pieced together. So I'll touch on the strongly recommended and recommended layers as well. This was for strongly recommended. These are basically, you can have service boundaries other than PSAP, police, fire, EMS. You can have Coast Guard, you can have the Forest Service, you can have poison control. You can have all of these different service boundaries loaded in these systems, so that if you have to transfer a call to have it handled by a different service, that you have a boundary to help relay and convey that call where it needs to go. It follows the same structure as the rest of the service boundaries. And then you have the polygon depiction of these A1, A2, A3. So your states, counties, incorporated municipality, unincorporated in your neighborhoods. And it's strongly recommended for this MDS is what I mentioned before, the mapping data service. This is really, again, more for map display. The mapping data service is, I'm really not going to go down that rabbit hole, because whether it exists and how it is used is still pretty hotly debated in a lot of the work groups. But just think of it as a true map display service. And so that is where, again, all of these attributes being built into the roads and points mean that's how they're used for validation. But for map display, if you want to see your state boundaries, your county boundaries, all those things, these are the polygon representations of them. And this is just another way of showing it with a fun graphic of polygons, in case you don't know what polygons are. And because you got to throw some pictures in here, or otherwise it's endless tables. Then recommended, this goes further into the map display world. And again, every time we have comments or things that come up in the work group related to like railroad center lines or hydrology or these location and distance markers, it's kind of like, it's only recommended. It's not used to route a call. It's not used in the core services, but for a consistent universal map display, here are the layers that you can put together and the structure to follow. And an interesting one is this last one, this site structure address polygons. I don't know if anyone has heard of this before. This is new to version 3, soon to come out. And it is essentially the base level representation. Sorry, and again, more pictures. More of a representation of indoor spaces within. So it's like the polygon representation of that site, sub-site, and structure. This could just be building footprints. This could be polygons of larger sites and parks and things like that. It could be rooms within a building. This was an attempt to follow and incorporate some guidelines and requirements that came out of the 3D GIS requirements document from Nina. But when we get to the end of the day and we talk about some current and future standards, there's even more going on around indoor data and indoor building of indoor data than this. This is kind of like a starting place, and it'll be very much expanded upon. So this is, it's also interesting because this is where things like overlaps and gaps and polygons, where you cannot have them in your service boundaries. You can't have overlapping or gaps in PSAP polygons because you can't have a question mark as to where to route a call or a conflict in where to route a call. But here, when you're, again, this is a recommended layer. It's for map display. You can have stacked polygons here. You can have the site and the subsite and the structure and all those things stacked on top of each other, overlaps, gaps. It's no problem. Because it's really for map display only. So I've talked about a lot of things with version 3. I just wanted to touch on the timeline for it again. This is a version that had a lot of change to it and is due to come out by the end of this year. We're currently going through comment resolution from the public review. And that work group is going on right now. I had to tell my co-chairs, I'm sorry, I can't be on the work group call because I'm teaching about the standard in Colorado. And they're walking through a lot of comments that we got. I will say the majority of the comments were not necessarily what it's considered substantive. There are some, so anytime a comment prompts a substantive change, something that actually means a difference in how the standard is used, interpreted, et cetera, that will trigger a second public review. But then that second public review is limited to just what changed. So each time you have a next public review, it gets smaller and smaller, the content that's up for review and commentary. And that's what I have for the data model. I hope people are eyes open and nobody's snoring. So I'll call it a win in the room. I don't know remotely if I held on to
Especially after
everybody.
lunch.
Any other questions that have come through on that? And hopefully, Matt, it was not lightning round version.
No, that was referring to the dock picture, 88 miles an hour. Good job though, thanks.
Okay, no problem. I'm just thought I'd pick on you back a little bit.
You see this data model changing after version 3 before we actually get to where it's next gen, because
Right.
we're sitting at I think I can't remember if it was 2018 or 2020 that we moved to it,
Yeah.
and I'm not going to change
I know.
until we have more of a final version. until we-
Yes. So I don't know if you were on mic there, but I will repeat the question was, hey, do we think this is going to constantly change? Or when version 3 comes out, is there going to be another change after that? So it is a living document, but literally earlier this week with the co-chairs, we met to say, okay, coming up this fall is a meeting that Nina hosts called joint committee meetings, which is when all of the big standards and informational document work groups, the leaders, co-chairs, and a lot of like highly active members come together both in person and virtually to talk about issues that cross all Nina development efforts. And so we're putting together a presentation that talks specifically about, okay, we just had a scope for version 3 that was about 5 times the amount of stuff we originally planned. It is a lot of change, but there was a lot happening at the time. So what do we want to do next? And do we take a break, let people catch up, take a breath, let vendors catch up to the latest versions, and then plan what we want to start thinking about for version 4. I think that's where we're going to land. Our goal is not to be constantly having a moving target. And version 3 is a big change. So big that we had to create an appendix at the end of the document to handle all of the changes. It used to be covered in a table at the beginning. It would have made that table about 8 pages in and of itself if we had kept to that structure. So we put it in an appendix at the end of the standard to say, if you want a nice, concise way to look at exactly what changed in version 3, here's what it is. It helps data providers, it helps vendors, it helps programmers know what they need to do to accommodate the changes. And I think everybody wants to take a break because not everybody even brought everything up to version 2 compliance. They were like, hey, we got to version 1. Now there's this little change with 2. We're going to think about it, but we're not really going to commit yet. Version 3 is where I think a lot of people will have to make that leap, especially because it accommodates the CLDXF and I3 updates. So I see us taking a bit of a breather, a bit of a break, and then maybe once we start work on the next version, because technology is always changing. You can't stop it. And you have to accommodate for it. You can't just completely stop, but maybe just, again, give people a longer runway to catch up. And then, man, I don't want to say it out loud because I'll jinx it, but I don't know if we can really think of this same volume of change in a future version. Again, at the end of the day, I'll touch on some of the future work efforts, and it is more around indoors and some other things. So that's coming, but I don't think we need to tackle it like immediately based on some of the other NINA efforts. So hopefully we'll give people some time. That's kind of the plan. We just have to get all of NINA to agree. It's a little hurdle.
If you want to flip through version 2, I have a copy of it right here. So I like to print things out.
Yeah, it's a nice,
Like just snuggle with it.
yeah. Is that
Um,
two-sided or is that single?
Singles.
Single-sided,
Also, you can
okay.
take notes. about
Okay,
it too.
sure.
Not that I'm fun. But yeah, if you want to see, if you haven't seen it and you want to just kind of flip through it. Take a look, Greg.
Anyone else? I don't see any hands online. So I think,
How long do we want to break for? 5 minutes?
yeah, five, well,
5 minutes, stretch it out, get some coffee.
yeah.
Coffee, guys.
All right, we're taking a quick break for those online, getting some coffee, stretching the legs, waking people up, and then we'll be back.
All right, everybody online, we are going to continue. I hope you all got some coffee and stretched and maybe stepped outside for a second to get some sunshine if it's shiny outside. I'm not sure if it is.
Yeah.
Okay, so we're going to move on to the GIS data stewardship document here. The agenda includes, sorry, I'm working two screens here. Okay. So we've got the needed information document for GIS data stewardship for Next Generation 911. It's important to actually understand the meaning of stewardship, of course, right? So conducting, supervising, managing of something. In this case, it's the management of the GIS data. And we're talking about the general requirements common to all GIS data layers. So as Deb referenced earlier, the difference here with this information document, it's really advice and best practices versus the standard, which is more of like normative in its language and gives shalls and musts and directions and unifying standard about GIS data. So this document of stewardship is kind of how to maintain GIS for NG911 based on the standards. This is like the how-to, okay? And then after this document, I'm going to go through the transition document, but first we're going to start here because I think it's important to start with where we're trying to get to, right? This is more end state focused. So just a little note on that we will do the transition document next after this. Okay. So on your screen, if you want to download it, there's a QR code here. You can scan it and you can download it. It'll take you right to it. The document, the stewardship document, is going to cover data sets needed and how they're used, quality measures such as like the completeness, the accuracy, and topological consistency, the need for coordination and best practices for data exchange, recommendations and guidelines for managing NG911 layers, and then specific recommendations for the creation and maintenance of like service boundary layers and civic location layers. This is really a vital document for anyone who's looking to create and maintain GIS data for NG911. So in the room, who's that going to be? Okay, cool. All right. Just
It's not very enthusiastic over there. Come on.
all right. Cool. Okay. So it's important to consider the audience focus for this document. It's GIS and PSAP staff involved in NG911. So it's really aiming to make making this technical content accessible across different disciplines. Again, the goal here is what the GIS data should look like in a fully implemented NG911 system. So end state. So not necessarily during the transitional phases, because again, we'll talk about that later. The end state, of course, being an NG911 system that is in an EZINet and fully utilizes the capabilities of geospatial call routing in next-gen core services as well. The scope of the current version is going to cover PSAP and response agency service boundaries and road center lines. Future versions will include site structure address points and civic address inputs. So you'll see that not everything is covered in this one, but it does kind of put us off on the right foot, right? There's a lot of focus on road center lines, especially early on. So it's at least got good road center line content, and we'll see that. So just a key quote on stewardship: GIS data stewardship involves ongoing updates, collaboration, and maintenance, not just initial data creation. We'll talk about that too. It's not just a one and done, and then you walk away from it. It's ongoing. The underlying theme of it is collaboration is critical, right? So maintaining complete, accurate, and current GIS data for NG911 requires cooperation across multiple stakeholders and agencies. This is like, I think the theme of NG911 in general is collaboration, working with your neighbors, having the conversations, getting everybody involved, making sure that we are, covering all of our bases as this data is created and maintained going forward. All right.
One thing I'll just jump in and say
Yeah.
too is this is on its second version, the
Mhm.
stewardship document. The
Mhm.
first one, I think it was maybe around 2012-ish or something like that when it first started. And they wanted to go all in on all the layers right away. And Nina was like, that's too much. You got to start with just PSAP boundaries alone being the most critical layer for routing a call. So the first version focused on that. And then the next one, they expanded to, they actually formed two work groups. One focused on center lines and one focused on the emergency service boundaries. And then I think they'll never do that again because it was two work groups going at the same time that had to get their content to then merge into the original first version. And it became it became crazy, but, and then the site structure address points, there is a standalone INF that was put out around 2014 that just focuses on that already. And so I think they do want a future version of stewardship to incorporate that, but, there's a lot of GIS efforts going on in NENA, and there's only so many resources that, and it's all volunteer. So, and all the volunteers tend to work full-time jobs as well. And those are demanding. And so,
Yes.
so just to note that the only reason, address points aren't in there is because they have their own document for now and may eventually get incorporated, but, that's another good reference. We're not going to dive into that one, but it's out there as well.
Right, thank you.
Yeah.
Appreciate it. Okay, so table of contents, I skipped over items 1 and 2 because they're kind of standard. It's the executive overview and then document conventions. But on the screen here, you can see we have stewardship of GIS data used by the emergency call routing function and location validation function, as Deb kind of went over earlier. General requirements common to all NG911 GIS data layers, civic location layers, service boundary layers, long-term maintenance of NG911 GIS data, and then impacts and considerations. In this presentation, we're going to focus more on items 3, 4, and 5. 6, 7, 8, I'm going to move through a little bit more quickly just because we do have some time constraints. And quite honestly, I mean, these documents, you could spend 2 days talking about them. So we're not going to do that. I'm going to pass this around. My wonderful assistant, Greg, is going to start. But this is just for you guys to flip through. I really recommend online too, if you're anything like me, having it printed out and in front of you and bound. I know it's so nerdy, but it'll get you into the hottest nightclubs if you carry this with you. No, that's not true. But it's really helpful to have these printed out. You can wait on that one. Because then you can just pick it up, put it down. Sometimes it's hard to be sitting in front of a screen all day and then continue to sit in front of the screen and keep reading all this content. So that's a total sidebar. But I encourage you to spend the $6 to get it printed up. Okay. And maybe you can expense it. Who knows? All right. Okay, so this first section, I'll admit that we kind of cheated. We did grab a couple screen grabs from this. And then additionally, there's going to be some slides, especially as I go into the transition document, where I will literally read from the document, and I'm sorry, but quite honestly, it's been so heavily peer reviewed and there's been so much thought put into the language that I, as a single person, cannot do the language any better justice than it's currently written as. So that's why you might hear me do a little bit of reading. Okay, so again, stewardship of GIS data used by the LVF and ECRF, that's this section. Again, that location validation function is the pre-call function that validates location for service provisioning. And the emergency call routing function that ECRF gives location and route to the emergency service routing proxy, ESRP, so it can move the call to the next IP hop and then get it to the right PSAP. So in this section, we're going to explore the roles and coordination duties involved in aggregating 911 GIS data layers. This is an often misunderstood topic because much of the work is done at the local level, while aggregation happens regionally or statewide, right? So a lot of this data is kind of being rolled up. We start locally, maybe you start at like a city level or PSAP level, and it rolls up to like a county. Maybe there's a region or a Digby, or it depends on how your state is structured. But the data rolls up. So roles and coordination are especially important to understand with NG911. All right. Sorry, I have to progress on 2 different screens because I'm silly. Okay. Coordination roles and responsibilities. So there's really 2 main entities to this, right? There's the GIS data provider and the 911 authority. So it's important to understand the distinctness of these roles, right? So the GIS data provider is typically the expert responsible for creating and maintaining the GIS data, right? So they have like the know-how. And then the 911 authority ensures that this data is built to meet required standards and is compatible with the next-gen core service provider's system. So the GIS provider, to break it down a little further, they may create and maintain original data source and aggregate source data from multiple GIS data sources. Does anybody here GIS, do you have to aggregate data from multiple sources? Yeah? Okay, cool. It's fun, right? Different schemas, different, yeah. Must work with the 911 authority to determine the appropriate GIS data source. Now, you might be structured where your GIS is already like within the PSAP. There's a lot of different ways that you can have your agency structured. So you might have that blessing of having the direct tie to the PSAP. May provide civic location data for all or only a portion of the service boundary area. So depending on the surface boundaries and how that's set up, it might be kind of split apart. GIS data provider is responsible for performing quality control checks on the data within their area, ensuring that it conforms to NENA standards. Now, the 911 authority is the responsible party, but the GIS data provider, as the one who is providing the data, does have some responsibilities there as well. So 911 authority, that could of course be a state or county or region responsible for 911 service operations in a given area. Might be comprised of one or more PSAPs. Does anybody have that situation? Yeah, cool, okay, fun, right? May assume the role of GIS data provider for the service area boundary. That's what I was just talking about. Or it may delegate that function to other entities, entity or entities. So some, places are working with different vendors. There's a need to specify exactly how and by whom local data will be reviewed and edge matched. We'll talk about edge matching in a little bit. And then lastly, need to specify how boundary issues are resolved and how final quality control measures are performed before the data are provided to the spatial interface, right? So that spatial interface, I'm not sure if it was on, I don't think it was on our earlier graphic, but it's kind of like the bridge into like all the next gen core service functional elements utilizing GIS. Let's see here. Yeah, nothing else to mention on this. Is there anything that you want to add?
I'm good.
Okay, cool. Boop. All right. Coordination roles and responsibilities. So a formal agreement is recommended between the GIS data providers and the 911 authority when data is aggregated by third parties. So this is, I think a lot of us understand, especially working for a governmental agency, that you really don't want to have just like a handshake or just like a verbal discussion of like, yeah, I got this, you got that, it's good. Because that can kind of come back and bite you later, right? So having the formal agreements really outlines, who can edit the GIS data, what changes each entity is allowed to make, right? Because I would love to think as a GIS person, I can just move that boundary and like, oh, I'm just moving some nodes. It's fine, no big deal. But it does have implications down the line, especially for first responders. Fire chief comes in and says, hey, why did you move my fire boundary? You don't want to be in that situation. So identifying which entity and what changes they can make is important, right? And then how parties are notified of changes, right? It's not fun to like potentially be sitting in 911 and find out that maybe like where your GIS data originated, some changes happened, annexations, you didn't know about it, you find out about it later. That's, something that you want to avoid. So notification of changes, blasting open communication channels, that's really important.
And I will just add, this kind of speaks to a larger concept around overall just workflow and standard operating procedure documentation. 911 world is heavily driven by process and procedure. On the GIS side, whenever I give presentations about the importance, and I hammer it home about the importance of documenting what your processes are, and then I like to ask, like, who has great processes documented, and saved where everybody knows where they are and everybody knows the role that they play. And there's barely a hand raised in the room. So I keep hammering it on presentations because for so many different reasons, it's so critical, especially because every position has turnover. Anytime, you may be doing a job and then something happens, you move to a different role, whatever it is, and somebody steps into your shoes and they have to know all this stuff, and you don't want somebody trying to recreate things that, and going through all the pain points that you have already resolved. So I highly encourage anyone who is in this role of a GIS data provider to document what you do and who you notify and what the no shrugs. Come on. No guesswork. Identify it, document it, and then yes, put it somewhere that everybody knows where it's saved. Don't put it on your C drive. Don't put it on your desktop. And then like
A little USB.
yeah, your laptop's
and
on the
throw it in your
fritz
backpack.
and there goes all your documentation. So just highly, highly encourage people to really think about that as a project to undertake, is to think about the roles and responsibilities, who's doing what, and to document it all in a good, safe location and revisit it, you know, maybe once a year, because things change. So
Thank you.
off my soapbox.
No, it's a good soapbox to be on. Last bullet point here. So Engine 91 system discrepancy reports should be sent to the entity designated by the 911 authority for resolution. This is, I think, pretty intuitive, but super crucial. Deb did mention earlier the agency discrepancy ID fields. So it kind of goes hand in hand with that. But, you know, making sure that the discrepancies are actually being resolved is very important. Okay. So aggregation of Engine 91 data layers to regional or statewide data sets. Number of reasons here, right? So this improves database integrity across the state or region by having a common schema, right? So again, Engine 91, I'm trying to get into common schemas here. Ensures a common coordinate system within the state prior to providing the layer to the next gen core services. Also enables the creation and application of consistent topology rules across the aggregated data set. Here's a fun little graphic for the non-GIS people to kind of illustrate some really fundamental topology concepts. But let's say for like a road center line, we don't want to have overshoots, undershoots, things like that. And we want to make sure that we have consistent topology, you know, with our neighbors as well. So we're all following kind of the same rules. Single reference. So this provides a single reference that could be used to coordinate NG911 GIS data layers along states' borders. Additionally, create a common layer that can be used to support interaction with one or more NG911 service providers within the state, and provides a common data set that can be used to engage a neutral third party to help with NG911 GIS data layer reconciliation. Obviously, the word up here we're seeing a lot is common, right? So it's the stewardship is about, you know, the data is standardized, it's the single reference, it's common, it's accessible. So, you know, I'm thinking like a lot of us have, you know, maybe like a CAD to CAD agreement with a neighbor where it's like you send them your data, they send you yours. But ultimately, you know, you want to make sure that the authoritative data for what you have for like the county next door is what they have for themselves. That's kind of the theme here. Okay, questions? Riveted? Awesome. All right. Okay.
Doing great.
All right, so GIS data synchronization. So I'm just going to read this directly from the document, but topology describes the spatial relationships between the GIS features, right? So road center lines within service boundaries, for example, and must be considered when developing or maintaining NG911 GIS data layers. When a specific relationship between features is desired, topology rules need to be developed to enforce that relationship, right? So topology rules being something like RCL, you know, fully contained within a polygon. There's more to it, right? Where we're snapping our RCLs to a node on the polygon, but we're establishing these rules for our features to make sure that like from a geometric perspective, they are sound. Additionally, for GIS data synchronization, snap 2 points. Now, some of us know them as like anchor points, agreement points, stitch points, edge match points. You can see on the screen here, we've got an example of, you know, nodes versus edges for the non-GIS people in the room. Something I want to note here is earlier, or maybe I didn't mention it earlier, could be coming, I can't remember. Talking about transformations. So next gen core services, or Engine 91, it's WGIS 84. Okay, that's going to be our coordinate system. If you are in a situation like, let's say we have a single segment, right? And the starting node and ending node, this is on a boundary. It's our neighbor has the exact same starting and ending node, but maybe they have some RCLs that you don't have. And so they come across and they terminate. And so they have additional nodes along that boundary. Even though the first starting node and the last starting node, and I'm sorry if you can't see me online here, even if they're in the same location, if your neighbor has additional nodes along that same straight segment, and then you guys go through a transformation, you could potentially be opening up a sliver or a gap in your boundaries. So it's really, really important that you literally have your nodes matching your neighbor's nodes, because in the transformation process, it's entirely possible to have gaps or slivers open up. Anything you want to add?
I just wondered if you kept the graphic from the other presentation about gaps.
Oh, I do. Yes. Yes. It's very, very dramatic. Look forward to it, guys.
That's just a teaser.
Yeah, it'll wake you up.
There's some fun graphics
Like,
coming
oh.
up.
Okay. So next section, general requirements common to all NG91 GIS data layers. again, we are blasting through this super fast. I know it might feel a little slow right now, but I assure you, we are cruising through this document. So in this portion, there's use of coordinate systems within an engineering system. There's also talks about accuracy and precision. So we'll look a little bit more closely at that. All right, this next graphic is to give the warm and fuzzies to the GIS people in the room. It's kind of a security blanket to see projections. But again, we're using the World Geodetic System of 1984, WGIS 84, EPSG 4326. I couldn't remember from like GIS 101 what EPSG stands for. Does anybody, GIS people, do you
Oh.
guys remember what it stands for? Because I was like, ellipsoid something. This is just a fun
No.
quiz.
What I honestly, I'm not even gonna guess because I did have to dig into this at one point
So
because
random.
it seems like why it's so old. Why are we using that? And it goes back to
I can't wait to tell you.
all of NG 911.
Yes, that's what it is, right?
Thank you for Googling.
Who would have guessed that, right? Yeah. So I looked that up because.
But this is mandated by the IETF, the Internet Engineering Task Force? Task Force.
Yes.
Yes, thank you. I was like, TF. So they are the ones because I3 is meant to be a truly global standard, not US based, not even North America based. This is based off international internet protocols. And there are there are a whole lot of things that govern this. And one of them is there is a mandate to use this particular projection and coordinate system for all data within NG 911. And there's a notion about trying to come up with or changing it to something more modern. But in order to do that, you need to bring that consideration to the IETF itself and have that trickle down into these RFCs that then govern the I3 standard that then govern the data model. So it's not as simple as going, that's old, we should pick a different one or a better one. These are globally mandated things. So just wanted to throw that in there that 1984 is getting farther and farther behind us. You know, why can't we modernize? It is a mandate that we're stuck with for a while until we can solicit IETF and make a case to change it. So
Cool, thanks.
Yeah.
So this is another quote directly from the document. While the local GIS data may be kept in any geographic or projected coordinate system, it must be able to be transformed into WGS 84. So of course, locally, if you're working in one projection, you could continue to do so, but just be mindful of transformations. And they do have the potential to open up slivers and gaps because of course it really comes down to math, right? And precision, things like that. So I would not just assume that if you transform your data that it's going to be absolutely flawless on the other end of that. Okay. Slide. All right, here's the minority report slide. Okay. Nina globally unique IDs. Well, first I'll just point out on here, I just put in italics here, refer to current GIS data model for creation, right? Because that's where the standard is. That's really housing, you know, how that can be created, how it should be created. So I'm not going to go hardcore into that, but every feature in each GIS data layer must be assigned a NINA globally unique identifier, an NGU ID. So this is like, and you can feel free to chime in here, composite basically of a local unique ID with additional components to it. So of course that means that our local ID, especially within an agency, should be unique, right? Because if we have two local UIDs that we're using and they're identical, and then we're rolling it up into something higher up, potentially we're still introducing more duplication there. So just be mindful about that. I think most of the GIS people know this, but when you're doing your local UIDs, object ID is not a great idea. I think of it like a temporary tattoo. It's not anything that you can rely on. So I would not be using object ID to help calculate your local ID, which helps feed into your NGU ID, because the object ID, at least, I mean, I think we're speaking Esri here, but it's not necessarily permanent. Okay, so just heads up on that. A stable and persistent local unique ID is strongly recommended as it serves as the basis for NGUID creation, regardless of the level at which the NGUID is maintained. So that's really what I was just saying there. The NGUID maintenance process may differ based on GIS data workflows with various levels of the GIS data maintenance hierarchy, for example, city, county, region, or statewide data aggregation. The NGUID may not need to be maintained at the most local level, but may be managed at a larger aggregating level. So it's possible, you know, some of like the smaller entities don't really have to get tied up into NGUID concerns, but at a higher level, as it's getting, you know, provisioned and it's working in next gen core service functional elements, it needs to be there. So questions on that?
Did you say in last meeting they had that they were gonna do the globally unique ID, the 13 character one that usually is generated into.
That might have been referring to the local unique ID because the NGU ID is huge. It's a lot bigger than 13 characters. Yeah, it has the, off the top of my head, you're challenging me. Yeah, there's the local ID, there's an indicator for what the layer is, like a shorthand like RCL and SSAP. Then there's a URN that is specific to it being a GIS layer. And then there's the domain for the agency. It's either the same as the discrepancy agency or it's an agency it's just called agency identifier. So you end up with these NGU IDs that are quite long. And sometimes if you're using a system that already has a complicated, what they call a global unique ID as the local ID, it gets bigger and bigger and bigger. But it is very guaranteed to be unique.
Yeah, so if you want to pass this down at the bottom here, there's a bunch of examples.
Yeah.
It's kind of nice though, because it's kind of got like its own like trail of breadcrumbs, you know, that you can kind of
Mhm.
follow things backward. So it's kind of intelligent. I think it's how it's designed there.
Yeah.
All right, so notes on accuracy and precision. So horizontal accuracy, more acronyms, sorry guys, should meet the National Spatial Data Infrastructure, NSDI's National Standard for Spatial Data Accuracy. I don't know, are we saying this NSDA, NSSDA? I'm not sure.
I don't.
I'm gonna call it NSDA.
Sure. Go with it.
The scale of 1 to 5,000. Now I had to look that up. So that translates to a horizontal accuracy of approximately plus or minus 13.89 feet or roughly 4.23 meters. Both of them very interesting numbers at a 95% confidence. So we have some horizontal accuracy that it should meet. There is a little caveat though. So where the GIS represents area features or legal boundaries with a point, such as a centroid for a parcel, for a building footprint or parcel, the standard is not applicable, but the GIS feature should fall within the corresponding area or boundary, right? So we don't have to have the horizontal accuracy super tied down for when a point is representing a polygon, but that point should still fall into its respective boundary area to make sure that it can be, you know, the QC, QA, everything checks out to make sure the point is referencing what it should be referencing within that polygon. If that makes sense. Vertical accuracy. Based on evolving standards, regulations, and technological capabilities, it can be expected that it will become increasingly frequent that accurate vertical elevation information will be arriving to PSAPs regarding where a call originated. It will be equally important for GIS professionals to incorporate vertical data and accuracy requirements into data sets used to support NG911. Basically, it's saying winter is coming, right? So, but look for more guidance in future versions. Okay. Cool.
Yeah, when this was published, well, certainly version 3 of data model, and I want to say 3D GIS requirements and these other things had not yet been finalized. So the informational documents have to take their guidance from the standards. And if the standards haven't been updated because other things were in motion, you get, like, again, you know, winter is coming, but you don't know exactly what guidance to give yet. And so some things are slated for future work and they'll open the work group back up and they'll do another version of stewardship that'll start to incorporate this guidance more and more as things evolve.
So some notes on accuracy and precision in metadata. GIS database precision, when merging data from different GIS databases, differences in the precision value of the GIS databases may create slivers and gaps when consolidating the data into the location validation function in ECRF. We talked about this a bit earlier. Currently, NINA has not established a standard for GIS database precision. So that's from page 117, in case you're curious. Metadata, who remembers like metadata? Who knows what this is? The GIS people should be like, oh, great, metadata, awesome. Somebody want to explain what metadata is for the non-GIS people? Yeah, that's always what they give you in GIS 101, right? So within GIS in your layers, you have the ability to store additional information that just kind of talks about, you know, where the data originated, projections, sources, anything in there that kind of tells us the story of the data to kind of help, because this data can reach the hands of many, right? And so if you get a data set and you're like, oh, these points are awesome, but I don't know anything about where they came from or anything, like just
How
anything
they were
about them,
built, yeah.
how they were built, you know, any sort of precision, any like, you know, what if some random person just threw together a bunch of points down, like, well, can I trust this? I'm gonna look at the metadata and see like how valid is this truly. So documenting any limitations or constraints metadata is strongly recommended by NINA and reflect the respective level of collection. So including the metadata as part of the stewardship, right? Being a good steward of the data, you want to have metadata in there as well. That way, if you leave your role or, you know, your data gets passed, if you're at the city and it goes on to the county and then it goes up to the region and it goes up to the state, the breadcrumbs are there. You know where the data came from, and you know a bit about it more so than just the actual like data that's sitting in that layer. Cool. All right, civic location layers. We're on section 5 now. We're going to talk a bit about road center lines. Let's see. We'll go a little bit into some of the specifics here, like cul-de-sacs, things like that, stacked road center lines. I kind of nerd out and I find this stuff interesting, but all right. The purpose of the road center lines, we touched on it earlier. This layer is used by the LVF to validate a civic address and is used by the ECRF to perform a geographic query for a civic location against service boundaries to determine which PSAP an emergency request is routed and which emergency responders are applicable. Basically, the road center lines are important and can be used for routing, spatial call routing, okay? Also, you can use the road center lines for vehicle call routing. It's a little different, but RCLs are important. That's all we have to care about for this slide. Okay. All right, so site structure address points are essential for those areas where RCL layer is incapable of providing location validation accurately. Jurisdictions should plan on developing a complete SSAP layer if they do not already have one. So as it was mentioned earlier, site structure address points became required, but it didn't necessarily have to be complete. But, you know, I describe a site structure address point layer as kind of like the page number of a book, and the RCL is like a chapter, right? So the RCL is good to have because it kind of gets you to the general area, but more specifically, having site structure address point really helps to hone in specifically to an XY, right? So it's a more precise location. Jurisdictions should build a complete site structure address point layer. Of course, we have limitations, right? Resources, funding, just bandwidth, that can be a challenge. But really taking the steps to, I can't remember which document it is, you might know this. It talks about starting off, it might actually be this one. No, maybe it's not. It talks about starting off with like what you can do, right? So maybe you can't do every single sub address unit and, you know, getting down to like the floor level for all your address points, but at least get the basic address points ready to go, right? And then as you get more time to work with them, adding more and more granularity to them to make them more precise and complete. That's one way to approach it, sort of a phased approach, just to kind of get you going, right? So you don't have to start off super, super granular right off the bat. I can't remember which document that is. It's in a document. Okay, so syncing road center lines and address points with AMSAG Alley for address verification. Talks about this a bit more in the transition document, but this is really important as we're supporting legacy systems alongside with going into next gen core services, or sorry, NG 911. It's important to be able to support both systems, because if you're at a PSAP that's like super, super modern and you have everything ready to go, but you're also transferring calls to other PSAPs that aren't quite where you're at, you have to make sure that you can send them information, they can send you information, and you can work with that all together. Additionally, they should be telling the same story. So if I had to rely on my MSTAG, my Master Street Address Guide, for routing the call, the information, the data that's within the Master Street Address Guide I should come to the same conclusion if I were to actually use my GIS data to spatially route that same call. So it's important to sync them together. Use the NINA civic location data exchange format standard before next-gen core services upload, and then see NINA site structure address point GIS data document for details. So this is just more information. It's kind of leading you to different documents, but you know, some of these documents are standards, so it's important to be looking at those even though you're working in an informational document here.
And I'll just do one caveat too, is
Yeah.
that, as I kind of touched on before, whatever NG911 deployment you're in, your core service provider may have its own set of requirements and rules around the uploads or nuances to how to populate the data, not veering away from the standard, but just if there's specific ways to populate things that are not as mandated. So just be aware that these are standards and informational documents to give guidance, but, and I think it's referenced a lot in the document as well. There are some things where you have to just work with your core service provider to get specific instruction on some things, and it may give even more detailed guidance on how to do these things. Which is beneficial then, you know that it's being handled the appropriate way. But just to be aware, there will likely be specific guidance, rules, et cetera, that come from that provider as well.
The same data should be used for call routing and location validation, and it should also be used for other purposes to mitigate conflicts between the 911 system and the PSAP's ancillary systems. So like computer aided dispatch, mapped alley displays, and then transportation planning. So this is somewhat intuitive, right? But it's entirely possible to have one data set that goes to NG911 spatial call routing and have a whole different data set that's operating your CAD system. You know, ideally, you would want to have it be the same data, but just like dressed in different clothing to meet the different needs, right? So, oh, sorry, thank you.
That's right.
We'll talk about ETL a bit later, but you know, if you don't want to necessarily have your CAD system have like completely different address points than what you are submitting into like the SI, because it's just a mess. It's just disparate data systems. So yeah, be thinking about workflows in which you can ensure that your CAD data, even though it might be a little different, right? Because it is tweaked for your CAD system, it should still align well with what you are submitting for spatial call routing. Cool. All right. ETL. So it's not expected that GIS data providers adopt the next-gen GIS data model for internal use, but it is expected that data providers be capable of exporting their external GIS data model into a format that complies with NG911. So I like to equate this to like, okay, when you're working with your data locally, you have it work for you in such a way that it's meeting your needs at the local level, right? At what the functions you have to perform, what the data has to do. And you're going to have to potentially change it to comply with the NG911 standards. That does not mean you have to take the NG911 standards and work that backwards and use that as your new model at your local level. It's kind of like, you know, assigning a new address. Like people are not necessarily receptive to receiving a new address. You don't necessarily want to have to be forced to take the NG911 data model and bring it into your local workflow. So you could use what you're working on currently, and then through extract transform load or extract translate load. I'm seeing both. I prefer transform. You can, I said, change the clothing. You can change it so it meets next-gen core services. So maybe, for example, locally, when you have your address points, maybe you're storing some extra stuff in there that's just helpful for you, for like your first responders. I don't know, crosswalks or like trailheads, things that are kind of like just helpful for you at the dispatch center. But for next gen 911, maybe you pull that stuff out because maybe it fits better for a next gen 911. So you can transform the data as you need to. Now, this could be done, if this intimidates you, you could talk to a public safety GIS vendor, or you could do it through potentially a series of scripts and tools that you design yourself if you are advanced in GIS. But again, if it intimidates you, reach out to some of the different public safety GIS vendors, because we can certainly help you with this. Cool. Okay, single, multiple, and stacked road center lines. I've seen this personally working at a dispatch center. We had a street that had like 4 different names, so we just had a bunch of like stacked geometries. Try to avoid that. CAD systems really don't like it. Sometimes you might have to though, especially if you have addressing that correlates with like one road name and not the other, and they follow like 3 different patterns. So like if you have like a Pine Street that's like, I'm 1 to 300, but I'm also US 54 and I'm 2000 to 3000. Sometimes you have to do some ugly geometry work to make things work for unusual addressing. But it is discouraged for routing, especially, if you can come up with utilizing like street alias tables to accommodate that, definitely do that instead. I'm sure that there's multiple implications for it, but having stacked geometries, as I understand it, in a CAD system, depending on who you have, if you have history attached to responses in that area, if it attaches to one road centerline segment, but not the other, and you go back and you want to do some like analysis and say, hey, how many car accidents do we have at this location? You potentially might not be getting the full story if you're only getting the information that's tied to one segment, but not the other, right? And if you have 4 segments, you're diluting it by like what, 75%? I can't do math right now. So avoid stacked road center lines. They can be single or dual carriageways. We'll look at a couple different intersections, I think, in a couple slides. Maybe it's a little further down.
Yeah, this is something where for routing a call, it doesn't matter. For
Yeah.
routing a call, you validate a location, you route it to the right PSAP, it's done, right? But CAD is a whole other animal. And each CAD will have its own requirements and its own allowances and rejections, non-allowances, non-requirements, things that you can or can't do within each system. So oh, there it is.
This is a dramatic one, yeah.
I love it. I love this graphic.
I think I was watching Mad Men or something. I feel like that's right. Yeah.
So yeah, go ahead.
Sorry. Okay. So, spatial gaps and overlaps. I'm sorry, guys. We've hit on this so many times, but it really is so important. It's a critical error. You can't be having gaps and overlaps between some of your topology and also like your PSAP boundaries, your provisioning boundaries. You can't have any gaps there. So again, this goes back to topology, of course. But snap road endpoints to avoid geometry issues, especially when merging data. Endpoints at service boundaries must align across jurisdictions. This is considered a critical error. So, NG91 is IP based and it will do what it can to band-aid certain things. But at a certain point, it's like, I don't have enough information. I cannot put a band-aid on this for you. Critical error. And then it gets handled differently. So I think what is it? It's like a default call. I'm trying to remember where it goes.
Yeah, so we're kind of mixing a couple things here between gaps, overlaps, and boundaries versus roads. When it's boundaries, if there's a gap or an overlap and either a lack of information or a conflict of information, generally the systems will have a default route programmed in. And it might mean that in a statewide deployment, they've identified one PSAP to handle statewide any sort of orphaned or misrouted calls. And so it's good to have that fail-safe. But then you end up at a call center that you could be getting calls for your own area. You could be getting calls statewide, and you have to have that statewide data built in to validate and help reroute it where it needs to go. But all of those things obviously involve more call transfers, extended handling of the call, a delay in response, and the potential for a negative outcome on the call or a bad outcome. So these are just things why we hammer on data accuracy and quality and QC and all of that so much is because the ultimate goal is to make the handling of that call and the dispatching of responders as fast and accurate as possible.
Okay, thank you. I'm going to move a little bit faster through some of these things because they can be really covered in 1 or 2 sentences here. So cul-de-sacs and coves, avoid true or Bezier curves due to transformation issues. So Bezier curve is based off of mathematical formulas. So of course, when we do transformations, mathematical formulas, that's what it's all based on, can cause issues. But you want to represent cul-de-sacs and coves with a straight line, even if an island exists. So on the left here, you can see we have an island in that cul-de-sac. It's acceptable to represent it as just a straight line, especially because CAD systems, and again, I'm talking about vehicle routing here, but when you draw, a cul-de-sac, if you come around like a lollipop and that segment intersects with itself, that can be a problem. It's considered a self-intersecting segment. That can cause issues. What's up?
Clearly, or just in cul-de-sac?
In the stewardship document, it's just saying to avoid the Bezier curves due to transformation issues. But
Yeah,
it is listed under cul-de-sacs,
it's
so.
listed here, but it is data set wide, and it really is because, again, when you have a mathematical interpretation of how a curve is, it means you don't have these specific nodes depicting how that curve is going to go. And when you're transforming it from different coordinate systems, it can get goofed in the transformation and end up doing some pretty crazy things to your roads.
Well, that'd be more important. Firewall, PSAP boundaries, the boundaries itself versus the road.
Everything. The transformations can cause what once was a nice depicted curve in a map display to become this straight line or zigzag or something, and it might even, depending on its proximity to polygon boundaries and other things, it could skew it and cause it to cross a boundary. It could cause all kinds of different things in the transformation process.
We have a lot of.
I'm gonna,
They're not crossing boundaries.
right.
So.
I wouldn't take it as something that you instantly have to go and change all this stuff, because again, a lot of times this will come down to your NG911 deployment and what they consider complex geometry, things that their system can't handle. And these types of curves may be one of them. So as a best practice, yes, it is better to avoid, but if you have them in your data, don't take drastic action yet until you have specific NG core service provider guidance that says we can't take them, we can't handle them, or bad, crazy things are going to happen if they stay in there. And then it would be the time to consider making changes if that's required. Yeah. Don't hit the panic button yet. Right. I just put them all in.
So pretty, yeah.
They look so nice.
All right. So road center line splits at boundaries. I think a lot of us at this point the GIS people are familiar with this, right? So when we're having the attribute values change, that can impact, I guess initially spatial call routing, but especially like the responding agencies that are going to serve that area. You're gonna be splitting road center lines. So where there's an NG911 attribute value change. Consider additional splits for geocoding accuracy. Now you don't have to go bananas on this, but especially like in this picture, right? Where we have these super, super long rural roads. First of all, in these areas, it's much more common that you're going to have some crazy addressing that shows up where it'll be like, 100 Meadow Lane, and then it jumps to like 23,000 Meadow Lane or something. Like it just gets really crazy because some of these addresses came to be like 300 years ago, right? But if you're using a single road centerline geometry to represent that entire stretch, and you have to come up with ranging to encompass all of those addresses, you can get some really wonky geocoding. I think you mentioned this earlier, right? If you geocode based on the address point itself, versus the road center line, if the road center line ranging is really off, you can get two entirely different answers from the system on where that call is supposed to go or where the vehicle is supposed to go. So just be mindful, especially in rural areas, we get these really, really long stretches. Turn on your fishbones if you have fishbones, and just kind of see like what that relationship actually is. Because if you get those super, super long fishbones, that's an indicator that maybe there's an opportunity to kind of tighten up some of the ranging on the road center line.
And
Anyone add?
it talks more, it goes back to that notion of you can do QC on your roads, you can do QC on your address points, you can do QC on your boundaries, and they could all come up perfect. But when you start comparing the three of them together, suddenly you realize like there's an address that you're trying to validate on, and the point is in one polygon boundary, and the centerline derived location is in another polygon boundary. And depending on which one is being used to validate the location, you could end up with two different call routing answers in that query. So you want to, as much as possible, draw your boundaries so they encompass both potential geocoded locations in the same boundary. Just to make sure that, again, the call routes accurately the first time and less need for transfers.
So this is sort of like a mercy item thrown in here, but keeping in mind, if you can reduce unnecessary splitting, it's definitely recommended. So, jurisdictional boundaries should align with national natural breaks like intersections or bridges. Now you can't always control this, but if you can, you are potentially giving yourself an opportunity to have fewer road centerline splits, which is less maintenance. So this is just added in here to, you know, keep in mind additional splits for other system needs beyond NG 911.
This is where we tend to get into some interesting discussions when, say, transportation department wants to break roads where the pavement type changes.
Yes.
Or the speed limit changes, or a bunch of different things like that. You can end up with highly fragmented roads. And, you know, I'm sure everyone has experienced this, the competing business needs for one set of data. It's just a consideration to be aware of. The more you fragment your roads, you know, the more features that you have, it's never a great idea. But when you do have competing business practices, you have to find a way to compromise to make it work for all.
So multi-lane road intersections, in the document, there's some examples of how you can handle this. So sometimes the road is represented by two parallel road center lines, right? We see this at intersections a lot, especially if there's like a median in between. You'll see this. You can do the pinched on the left, so that's figure 5-1, or on the right, you can do, I call it the peanut butter cookie style, where it's the real ground truth intersection. Personally, I think I've seen the one on the left more often because it seems like it causes fewer vehicle routing issues, but
Well, I was gonna go a different direction and
Go
say
for it.
I actually scoped out a project once where a large city had a lot of this pinched. They had roads that were at each of one of these the intersections, and anytime a physical barrier broke for traffic, you know, it would pinch again. So they called it sausage links. Right?
Funny.
It was like a row of sausage links. And what happened was in their CAD vehicle routing, the voice turn by turn directions
Slight left, slight
would
right.
say, yeah, veer left
I've heard that too.
and then veer right. And so that was causing a lot of confusion in responder vehicles thinking they had to in fact turn left, and then they were getting, you know, turned around and big fire trucks. It was a big problem. So it was an entire project that was about turning sausage links into ladders, more like on the right. And that was how they overcame that. And that again is unique to that CAD system
Mhm.
and how that is handled. For next gen, this doesn't matter.
Yeah.
For validating a location to route a call, this doesn't matter. But when you're routing a vehicle and how that system handles the directions and the turn by turn vocalization, this could be a problem. So something to think about.
Mhm. But you'll see at the bottom, like Deb was just saying, either option is viable for LVF and ECRF, right? So that's cool. All right, and the CAD system is going to dictate what is preferable, like Deb just said. All right. So I was at a conference, I don't know, a couple years ago, and I was approached, and the guy was like, we had the situation where we had our ambulance going on an overpass, and then it was routed onto the underpass. Like, just take a left and just jump off the overpass. And I was like, oh, it sounds like an elevation issue. So that's what this is talking about here. So standard practice, split road center lines at grade intersections where two roads meet at the same elevation, right? So if you have two roads coming together and it's a viable option to turn without jumping off an overpass, you can split the road center lines there. And we'll see some examples on the next page. But it's also an option if, you know, if they are one's going over the other, to not have that split there, especially if elevation is not indicated, right? Because you don't want to split it there and make it think that you can actually turn onto a road that's at a different grade. So to maintain vehicle routability, road center lines must have elevation attributes or be split only at intersections with the same grade. All right, so that's what this is kind of illustrating. So this intersection's the same grade. So you can see there's a noxious kind of note here, but you have the option of turning, you know, turning at this intersection because it's all at one singular grade. This is showing, and this is directly from the document, and I'm sorry it's so small, but this is showing that the elevations are indicated here. So you can see every single segment is actually terminating when it comes to another segment, right? So they're all split up, they're all smaller segments, but it's okay because the elevation's indicated here. So the system knows if I'm on that lowest level, I can't just randomly jump up to the next higher level. So that's why we have 0 and then 1 and then 2, is to make that differentiation so the system understands it. On the next slide is the other option, where the elevation's not indicated. Everything is just a 0, 0, but you'll see that there's no terminating nodes. So these are much longer segments that go across the entire image. So when a vehicle is routed through here, it's only be given viable options as well. Questions on that? No. Okay. Relationship of legacy ESN and ESZs to service boundaries. We'll talk about that. All right. So emergency service zones, emergency service numbers. So emergency service zones, for those who are not familiar, that's kind of the relationship. And I think I have a slide on the next page and I might just jump to it. Yeah, here I'll jump to it. It's just basically, these are areas that are represented by different responding agencies and PSAPs, right? So on the left in the green, we can see we have like the sheriff's office is responding, and like Aspen Fire, Emerald EMS. The bottom right, we have the same fire and EMS agency, but the police changes, right? So we have a different zone. It's represented by a different emergency service number. So that's what that's referring to, is those emergency service numbers. I'm going to go back up again for a second. Okay. And then those items are legacy, right? So that's tabular information that's used to route 911 calls and assign emergency responders. Engine 911 is replacing this with spatial queries for more accurate and timely call routing. So now we're going to be going to separate layers of police, fire, EMS, to indicate that the responders that should be responding to those locations. I'm just going to move a little bit faster just so we can kind of get through this. Okay, service boundaries, no gaps, overlaps, talked about that. We talked about edge matching, legal versus functional boundaries. So you might initially start off with a legal boundary where it's just like a line that's just kind of thrown down arbitrarily because it represents something legal. But when it comes to actual response and call routing, it should be much more mindful of what that boundary should look like to make sure that the call is routed appropriately to the correct PSAP, and also that the correct responding agencies respond. Let's see here. Okay. All right. So long-term maintenance of Engine 911 GIS data. This is another really important thing to keep in mind, is the maintenance portion, right? So you're going to have ongoing updates. You want to have a workflow in which you can handle the ongoing updates, because you can't just, get your data cleaned up, get to end state and think that you're done, right? Because somebody's going to build something and then you have to go back and fix your RCLs, your address points. Be thinking about like things like feedback loops. So maybe, your GIS data provider is housed differently than the 911 authority. The 911 authority is getting information of, oh, we're missing these address points. Feedback loop would be go back to the data provider and communicate the missing address points, make sure that they're being added. Let's see, data validation. That's really important. QC, QA tools that are available to you. You can create them yourself, or you can work with a vendor to use QC, QA tools to ensure that your data continues to be NG 911 compliant. Anything you want to add to this? Good. Okay. All right, guys, we're nearing the end of this section and then we'll take a quick break. I know it's a lot. Same story with service boundaries, just ongoing updates, maintenance workflows, validation tasks. They should be repeated after updates to maintain data integrity and prevent misrouting. I gave the example of, if we're adding new addresses, okay, we've added new addresses, but wait a second, we also have to make sure we have the RCL in there as well, right? So if you're maintaining one, be thinking about how that impacts the other. That's kind of a weird order to do it in, but be mindful that, if you're adding an RCL, that you should, or adding address points, you should be checking like the ranges on your RCLs to make sure that they still encapsulate the address points. Things like fishbones, or, QC validations that are checking for, AP does not fall within the RCL are helpful for this kind of situation. All right. Impacts and considerations. All right, I'm not going to read all these. I'll let you guys read them, but GIS improves location precision for PSAPs and geospatial call routing. This is like the whole point of the presentation, right? We want to have really good GIS, and the stewardship of it is also extremely important. 911 authorities must maintain and provision GIS data to Engine 911 networks. Implementation timelines depend on available resources and existing data quality. Again, I've tried to take, you know, what is a monster document and distill it down. And even then, this was still a large number of slides. Yes, there it is. I apologize. I realize that this can be kind of dry to go through. But as you're working with your data, maybe this will kind of, you know, jog some in your memory, like, oh, this was mentioned in the stewardship document. Maybe I should go back and look at that. I encourage you to do that. So let's take a few minutes break before we go into the transition document. The transition document will definitely go faster. So please just hang in there, guys. We can do this. All right, let's take a 5-minute break.
You guys are doing great, and don't be afraid to raise your, or not raise your hand, but yeah, you
Yeah,
can raise your hand and
questions,
ask questions.
Okay, so we are gonna keep going here. I'm going to the transition section. I'm gonna move through kind of quickly. But you are welcome to read what's on the slides, and I'm just gonna cover this content a little fast now, so. Okay, so, I'm on the wrong slide. Here we go. Okay. So this document, it's another information document. The desire was to provide guidance to GIS professionals as they create, prepare, and maintain GIS data. So this is the transition portion. This is where most of us are at, right? So we are mostly focused on, synchronizing our MSAG and ALI with our GIS data. This is a very long process. This is not like the flip of a switch where we can just go and turn on the next gen 911 lights. So the transition phase is a very, very long one. And so this document is really to just assist with that whole process. The working group started back in May 2019. I believe the co-chairs were Jeff Ledbetter with Datamark, and then John Streeb, was he DECOG? I think he's DECOG.
Yeah, Texas.
Yep, Texas, and then Jessica Fry from Geocom.
Mhm.
And then final approval and published back in September 2024. So you can find this online. Just to touch on this really quickly. So this goes back to this, train analogy, how all these documents sort of fit together. So at the front of it is the I3 architecture document, followed by the civic location data exchange format, and then the 3D location data requirements, GIS data model, stewardship, transition, provisioning. So you can see how this transition one kind of follows on the tail end. A lot of the documents, one's towards the beginning, they inform other documents, right? So we saw earlier on Deb's slide how the I3 and the CLDXF sort of inform the GIS data model. But they do all work together. It's kind of arguable. I mean, you could make the train analogy where it starts, but it's, it's also considered multidimensional as well. So, but this is just one way to kind of visualize how everything ties together. Okay, so for this one, the document's target audience is primarily composed of GIS data providers that are supporting the transition from E911 to NG911, especially those that may not be very familiar with 911. We talked about what a GIS data provider is. And, additionally, more of the audience could be like, combinations of the 911 authority, local GIS professionals, consultants, adjunct authorities, etc. Okay. So the bottom line here, the goal really is to increase accuracy, efficiency, and reliability. The quote from the document is, while the documents of the data model and the stewardship information documents focus on the GIS needs of an end state NG911 system, this transition document provides guidance for migrating GIS data from the current state to that end state. Following the recommendations presented herein should result in more accurate, efficient, and reliable operation of GIS data. So that is the goal of this particular document. So if you're struggling, definitely get this document and flip through it. All right. Okay, so transitioning, most of us know this, but transitioning in this case, it's transition the GIS data to support NG911, and it involves unique goals and realities. It's really the path to the end state of I3 compliance. All right, GIS data can be transitioned using various approaches and methods. This is going to be really guided by, where you're at currently and what resources you have and, how you're planning to get to the end state. But regardless of the method, the goals will remain consistent. So we're really looking to get towards geospatial call routing, location validation, and then also other next-gen 911 core services. We want to support those. So that's the goal for this. Okay. All GIS data layers must meet both E911 and NG911 requirements during the transition. So I mentioned this earlier. So if one, if you're working with another PSAP that meets a neighbor and they are much smaller, they're more legacy based, and you are super, super advanced and you're more, you're just about there with spatial call routing and next-gen 911, you have to make sure that you can transfer calls back and forth. So that's why, again, we can't just have everything flip all at once. And then additionally, to make that happen, we have to ensure that our MSAG data and our GIS data are synchronized to telling the same story. I already talked about that, so I'm not going to go through that again. But the transition process is really, really lengthy. As I mentioned earlier, it's not just a super quick process to get through. Typically, you have to follow a phased approach
because this is like eating an elephant, right? You can't just do it all at once. And then each phase has distinct GIS requirements. Guidance does matter. So the complexity led to a peer-reviewed 68-page document. That's this document, because this is so complex, right? So a document was really identified as being needed because of this whole process. Anything else I want to mention? Not on this one. This happy retirement picture just makes me like, oh man, I feel like I'm so far away from retirement. But the reason I have this here is because ultimately the goal, you know, a lot of these, the legacy databases like MSAG and ALI, ultimately we want to retire them, right? Send them on their way, but it's going to take a long time to get there. So that's why I threw this picture in there. Okay. The meat and potatoes is the GIS transition from legacy to 911, NG 911, excuse me. But also in this document, it's responsibilities of stakeholders and GIS data transition, civic address location fields, address number and range fields during transition, community attribution, ESN and ESC during transition, quality control, impacts and considerations, abbreviations, terms and definitions. This is literally like the table of contents directly from the document. So if you want to read more about those things, you can look into this document for those. I'm going to delve a little bit further into some of them next. Yeah, so my brain's very strange. I always make these weird connections, but when I saw this conflicts may emerge between Master Street Address Guide and ALI and GIS, I immediately thought of like these super retro toys where they're kind of battling it out. It says may emerge, but quite honestly, like they're going to emerge. Like
Yeah.
it's going to happen. You're going to have, you know, Master Street Address Guide that's really not being maintained, and your GIS is fantastic, or you trust the MSAG more than the GIS. And then you kind of have to go back and see which one's, you know, more accurate, and then make adjustments. What would you like to say?
Well, and this kind of goes back to what I said about the legacy fields in the data model is
Mhm.
that because after literal decades spent on projects trying to align and synchronize this stuff, sometimes that comes out in my work in NINA where it's you try to pin down some of the I3 resources that are also part of the group and say, truly, what do we need to synchronize? What do we need to focus on? And that's where it came down to, again, the most important thing is to ensure that those legacy fields in the data model are character for character match to your MSAG. Even if it looks like your MSAG is bad data, sometimes the MSAG is difficult to fix, or it just, you fix the MSAG, but it doesn't necessarily always correspond to the ALI, just depends. It can be easier to fix the GIS to match an MSAG that may not be as accurate because again, that transitional stage and those transitional legacy fields are just about ensuring that a conversion can be made from legacy format to next gen format. So sometimes it simplifies things, but sometimes it also just, people want it to be completely right. And then you just have to fix it in both locations sometimes. It just depends.
And then this bottom portion too is important. You know, ongoing maintenance of the 911 data sets is essential. Of course, like Deb said, you're migrating from legacy formats and then updating to newer versions of the GIS data model. So as Deb mentioned, version 3 is kind of on the horizon and there were a lot of changes in there. So, you know, keep in mind that the versions are going to be changing a bit over time, but it sounds like this version 3 has quite a few changes, but all for the better.
Yeah.
So worth doing. Okay. All right, so this portion, it takes a village. Synchronizing these data sets may involve collaboration. And I've mentioned this before, but again, it's a huge theme of this, right? 911 authority, GIS data provider, MSAG coordinator. If you don't know who your MSAG coordinator is, please find out. That's important. Addressing authorities, and then CSP originating service providers. You'll have to be working with them, potentially with some of the MSAG stuff. And then successful synchronization requires a clearly communicated process, and then specific documented procedures. So these are just the bullet points that are pulled out from some, you know, literal excerpts from the document itself. I just threw it into bullet points. Okay. Play-Doh Fun Factory. So ETL is your friend. And I think of this like a Play-Doh Fun Factory, right? Where like the GIS data is the Play-Doh, and then like the Fun Factory portion is like the transformation, and then loading it is kind of how you're gonna, you know, play with it afterwards. But yeah, my analogies are interesting. GIS data can be maintained in the GIS data model or a local multi-use format that supports various GIS applications. So that's likely the latter is probably where you're currently at, right? Where you've had this GIS data for a while, it's meeting certain needs, you have it structured a certain way with certain fields, and you can continue to maintain it that way as long as you come up with a plan for transforming it so that it'll work for and comply with the GIS data model and work in NG911. So this ETL process enables call routing and location validation, integration with other systems like PSAP and response agency mapping applications. I realize that some of this is redundant, but that is the nature of some of these documents. And the reason that they're doing that is because these are really important concepts, right? So if it's mentioned multiple times in the document, well, if it's mentioned multiple times in this presentation, it's because it's mentioned multiple times in the document, and it's mentioned multiple times because it's a really important concept. Okay. So after completing the full transition to end state, certain legacy features may no longer be needed. We talked about that. That was our happy retirement slide. And Deb touched on this earlier, right? Your next gen core service provider may have additional GIS data requirements. So just because you're kind of at that end state and you're like, okay, it's ready, your next gen core service provider might be like, okay, well, we follow the standards too, but I also have these other requirements to make this work for you. So this kind of goes back to the slides we saw earlier with the GIS data providers and the 911 authorities as being really critical entities in these discussions, because your GIS data provider may not have all the information that the 911 authority does and vice versa. The 911 authority might have much stronger awareness of what the next gen core service provider is going to require. And that information has to kind of get back to the data provider to make sure that, we don't have to, clean up all this data and then be like, oh crap, we have to go back and fix something to make it work. Anything to add? Good. Cool. Okay. All right, guys, we are cruising. We are doing 88 miles per hour. All right. Okay. The data will be multi-use in nature, so proper planning helps mitigate negative impacts on all local systems that rely on GIS. So this is true for a lot of things, right? Plan ahead of time, be proactive, so you're not going backwards to have to fix something. Local GIS data will continue to support a wide range of applications. We talked about this earlier. Yeah, we don't need to harp on this too much, but this is in the document as well. Okay. Document highlights. Earlier we mentioned English language translation, that ELT. That's an alphanumeric description of the primary law enforcement, fire, and emergency medical service agencies associated. Basically, if you look on the screen here towards the middle of this graphic, you'll see it says, and I can't do with mouse. Can I do it with mouse? Yep. Yes, I can. Right here, it says no ELT available, and you'll see under law, fire, and EMS, it just says verify. That's what it's talking about when it says no ELT available. I'm not sure why an acronym was necessary there, but yeah, so that's what the ELT is. And we talked about the ESNs earlier.
Well, and the ELT will provide that primary fire medical and law when it is a known fixed address, civic address location. When it says the verify, that's a wireless call, right? Where it's being routed based off of a cell sector, and it doesn't have a specific location to provide that yet. That may, come through different mechanisms, but.
Great, thank you. So this portion talks about creation of the MSAG community and ESN, ESC polygons. I think quite honestly, most of us are already there. But there is a section in there that kind of details like how to begin and how to develop it. Phase 2, legacy database synchronization, synchronizing GIS data with legacy systems, identify and resolve conflicts, establish protocols for ongoing updates. We've talked about this quite a bit today. Phase 3, NG911 readiness support, GIS derived MSAG, right? So if our GIS data is fantastic, you could potentially create a GIS derived MSAG where you're creating the master street address guide from the GIS data itself. So of course, in doing that, you'd have much stronger synchronicity between the two, right? You can validate GIS data against the NG911 standards to support location validation and geospatial call routing, and then collaborate with next-gen core service providers to ensure GIS formats meet system requirements. Anything you want to add there? No? Okay. Guys, we're almost there. Okay. Creation, this is just continued. Accurate GIS data is essential for supporting the transition. Mentions more about the ESN and the MSAG. And this is, again, quite redundant, but this is part of the document. It's just kind of hitting home on these. It does give some really good examples. So like for accurate GIS data, attributes are essential. If a road segment is missing its emergency service number, a 911 call from that location may not route correctly. Or, if the GIS supports both legacy and Engine 911 systems, a site structure address point must include both legacy MSAG attributes and Engine 911 compliant geometry to ensure seamless service. So there's some good examples about this in the document as well. All right, from the document directly, synchronization is a first step to the ultimate reconciliation and subsequent temporary dual maintenance of the GIS data to legacy 911 databases. Successful synchronization of GIS and legacy 911 databases results in GIS data that contains the attributes necessary to successfully route legacy 911 calls. All right. Synchronization is used to identify and resolve the issues below. So some of these, if you have, QC QA tools, they might pull these out for you and show you anomalies. So for example, like MSAG ranges that do not exist in your road center line, or road center line ranges that are not included in the MSAG, right? So we're comparing first one direction and then back the other direction. ALI, so automatic location and identification, record addresses that are not represented by the address points. So that's kind of like, that call comes in and we don't have that address point in the GIS data. Watching for things like that to synchronize it. Lack of data integrity, causing anomalies within the GIS data that will prevent geocoding. And then of course we want to shell records in the ALI and MSAG that are not and should not be reflected in GIS data.
One thing I will note is that I've been involved in a number of NG 911 deployments around the country. And when we talk about synchronization, what a lot of NG core service providers will use as their benchmarks for going live is a comparison specifically of the ALI database against your GIS data. And it may be ALI to road center lines, or it could be center lines and address points. But the most central one is ALI to road center lines, because again, there's that caveat that the address points are a required layer, but not required to be complete. So they may not include all of the addresses. But, every record in an ALI database represents a known fixed location that a 911 call could be placed. And so being able to check that it finds a home in the GIS data and can be routed appropriately in an NG 911 environment tends to be a benchmark for go live. Do you have a question?
So one of my questions here, especially with Allen, we have several military bases here.
Yep.
And of course, when they built them, they said Fort Carson.
Yeah.
Well, Fort Carson doesn't exist as a road.
Yes.
So we have a real hard time trying to get service providers to try and change it to something that actually does exist with the data.
Yeah.
But we haven't been that successful to actually do any suggestions.
Yeah, I mean, your question about military bases, and I guess the interesting thing is that there is a larger DoD effort to modernize to next gen 911 as well. We're actually starting a fairly large project dealing with a lot of the Army bases, and so that and I previously worked on a number of the Marine Corps bases, so I know that there are efforts to build the data and modernize the systems. And hopefully that will also lead to more data sharing. Sharing meaning sensitive things are stripped out first from the military data before it is shared with the surrounding county. But the idea is, that these areas, these bases will have their own EZNets and infrastructure for an NG 911 environment, and how that ties into a state system is going to be unique to each state and each area. But it is definitely a focus and a priority, and there is work being done on, it's been done on the Marine Corps, and the Navy did a big effort. We're working on the Army, and I'm not sure where the Air Force stands as far as their efforts to do all of this addressing and data build yet, but it is definitely ramped up at the DoD to focus and prioritize it and build the data that needs to be built. So
to actually happen? Transition to?
It's happening now. Literally, we're launching a project this month on the Army stuff, and there's teams working on it. So it is happening, and in a lot of places it has been built and continues to be maintained. So it's just that sometimes the communication between the who's holding that data at the DoD and how to get it to the county, those right connections need to be made to do the data sharing and sign the right agreements to make that happen, right? And then again, not every state is live with next gen, and the military isn't live in the next gen environment yet. As everybody starts to turn these systems on and that interoperability becomes a true possibility, that's where even more of this will start to lock into place, and those transfers will be possible and the data sharing possible. Again, always with the caveat that it has to be allowed and shared and all the proper documentation signed, right? It is happening. Can I give you a timeline? No. But it's happening, I promise.
Okay, so key takeaways. I don't know if anybody watches Seinfeld, but there's this episode where Kramer has a boatload of keys, and I just thought about this because there was a lot of key takeaways from this. But transitioning to NG911 is a complex process, right? It's an evolutionary process that involves technological, operational, and economic and institutional change. GIS readiness varies by layer. Arbitrary targets like 98% may misrepresent true readiness. So 98% is a very like romantic thought of like synchronicity, but it doesn't tell the whole story. And so, you know, it could be a good starting off point, but I would not just stop there if you've heard about the 98% synchronicity. GIS readiness isn't about a single metric. It's about confidence. The goal is for data owners and PSAP authorities to feel assured that their GIS data meets all critical conditions for NG911 support. So that includes things like the GIS data is free of critical errors, GIS legacy road names align, GIS data ranges encompass all alley locations, items like that. Let's see what I want to talk about here. There was one thing that was important. Okay. There's a note here that says only one PSAP, a GIS derived MSAG, only one PSAP. So in this document, it's saying that in a GIS derived MSAG, only one PSAP can retain records for each road range and street name, requiring coordination with neighboring PSAPs to resolve overlaps found during alley to road centerline synchronization. At first, I didn't quite understand that, but I realized it really does make sense, you know, to have only, so you're not muddying the waters by having multiple. So if you have questions on the only one PSAP, that's what it's talking about. You can see that in one document. And then lastly, the GIS derived MSAG may use multiple authoritative sources and requires close coordination between GIS data providers and 911 authorities. So as you can tell, everything kind of came back full circle. Coordination, right? Collaboration, coordination, working with your neighbors. And then did you want to handle this portion?
Yeah.
Okay, cool.
So just to wrap things up, and this is just 2 slides, is a discussion about, you know, we went through the data model and stewardship and transition, and there's a lot of things going on, and there are some further efforts, work groups that are either recently launched or about to launch that are continuing to help provide structure and guidance on all things GIS and evolving technologies in 911. So one of those is indoor mapping. When we talked about data model, I mentioned the site structure address polygons as kind of a starting point for building out some potential indoor data. There is an entire requirements work group that launched about 2 to 3 weeks ago. It's that new. There was some pre-work done with kind of a focus group with a lot of the vendors that are in this space doing indoor mapping that came up with kind of a initial contribution for that work. And now that work group has launched and they are drafting the requirements around this indoor data and how it is to be used in public safety and 911 systems. So if you're interested, that is a work group you can even join if you have, if you want to learn or you want to contribute. And it is requirements for mapping indoor spaces. The work started in August, and the output of that will most likely be worked into a future version of the data model. When, I don't know. That's another part of the conversation we have to have at JCM is how quickly are they moving, and how quickly does it need to be included in the data model, all to be discussed and decided by Nina as far as the priorities and when to tackle that. But it is a work group that has begun its work. And now what's interesting is all of this stuff around GIS data, everything around location, it starts with an address and an accurately assigned address, right? And Nina used to have a book and publication around addressing systems for public safety. And it is out of print. It had 2 versions and both of them are out of print. And there's a staff person at Nina who fields a lot of the questions asked for like informational documents and standards. She said at one point something like 60+% of the communications she gets are around questions looking for guidance on assigning addresses. And that includes, I mean, all of the standards in play and all of the informational documents in play. The questions she gets, the vast majority are around help and guidance on addressing. And she only has these out of print and copyrighted books to provide guidance and can't really provide any guidance, right? So there in the Nina structure, the first thing you do is identify an issue and you fill out an issue submission form that says, hey, this is a thing. It needs to be addressed. We need help. We need to put together some sort of document or working group to work on this issue. That was filled out last fall and it was accepted. Yep, we need to do some work on this. We need to form a work group. But at the time there was, data model in its initial work, the indoor group in its work, there's something like 5, 6, 7, 8 different groups on GIS. And there's only so many GIS resources and with their full-time jobs that can dedicate this volunteer time to do all of this work. So you kind of have to, pick your battles and focus where you can. But myself and Carrie Brennan and Matt Garricky, Carrie works for Geocom and Matt Garricky runs the 911 GIS program for the state of Virginia, have come together as the 3 co-chairs for this future work group that will launch. Our plan is in 2026. We're doing an initial focus group that will that is actively drafting the initial contribution that will be the starting point for that work group effort. So that work has started this fall and we're hoping to put out the call for volunteers for the actual larger work group in either end of December, beginning of January, right before Nina has their standards and best practices conference in New Orleans in January. So that is coming up. It'll have guidance on addressing systems, on how to navigate, the books that were in existence and now out of print were all about really giving guidance for areas that were converting from rural out in box to organized addressing for the first time. Those are basically done. There might be a few random holdouts here and there in the country, but everybody's addressed. And now it's about how to understand and operate within the addressing system you're in. There's a lot of turnover in addressing authorities, GIS jobs, addressing jobs. There's just a lot of churn. It's like any industry, like any jobs, there's turnover. And so people coming in from a GIS background, this isn't stuff that's taught in college GIS courses, things around addressing systems. It's just not core curriculum, right? All of us GIS folks pretty much come from a natural resources background. I'm an ecology major. These aren't things that you learn before you get your on-the-job training. And if your on-the-job training doesn't have that core documentation, like I talked about before, and guidance on how to do the job, there's just a lack of good, helpful guidance information purely around that first critical step of assigning an organized, logical address and one that follows a scheme and that doesn't create confusion and chaos on the ground driving to locations. So it's very important work. It'll handle things like how to do your ordinances, how to notify people, when to think about readdressing. Readdressing being a very politically charged thing as well. So there's a lot of good stuff that's coming in that. And then further on the Nina side, a lot of this will all be used to revamp or generate some courses that Nina will offer to give even better and more thorough education and guidance on all of this. So if you are an addressing authority or have a love of addressing, just be on the lookout for that work group to launch in early 2026. And it'll be a lot of fun, but those addressing conversations can also very quickly turn into therapy. Everybody has bad addressing stories. I have dozens, and everybody has tons and tons of things. And our goal is to, sure, we will have some of that, but mostly we want to get a document published to help people out that are taking over these positions and really need to understand what the heck is an addressing system and what's a grid system, what's a linear system, how do I assign an address range, how do I do all of this to get it right from the assignment and then on into the future. Oh, hey Matt, you signing up? You volunteering?
You're probably gonna see both of us here at our 911 authority signing up.
Cool.
But no, I was gonna offer my old copy of that Nina addressing systems guide for sale for an exorbitant price, as well as my
Section on how you should
super,
consider using computers and assigning of addresses.
as well as my extremely old copy of the American Planning Association's street naming and address numbering guide.
Nice.
Gotta fund my happy retirement somehow.
Oh, yes, absolutely.
But more in reality, if anybody in Colorado is looking for a digital copy of those, just reach out to me and I'll email them to you.
Thank you.
Thank you, Matt. So I think that was the last
Yeah,
slide.
that's all we have.
No, if you hung in this far,
Oh, thank you so
thank
much.
you guys.
You guys are
We know it's a
troopers.
lot.
Troopers. All right, thanks all.
So
You
any other
guys-
questions before we cut the cord here?
Yeah, now is the time for questions. So if you have any. All right, well, I want to say thank you very much again to Deb and Lauren and Datamark. And again, this would be put onto our YouTube channel as part of our GIS informational series. And please plan to join us in October for the wrap-up session, which will be a review of all the questions asked throughout the summer and an Ask Me Anything. So if you want to bring a question to try and stump these GIS professionals, I don't think you're going to be able to do it, but give it your best shot, and we'll see you in October. Thanks, everybody.
Right. Thank
Thanks
you.
all.
Thank you, Datamark team.
Thank you.
Bye, guys.